The following is a presentation of the Six Arrows Radio Network.
Today on the Workbench, hacking the BitX40 with Mark, KR6ZY. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
This episode of the Workbench is brought to you by Elecraft, makers of high-performance radios, amplifiers, and other great station accessories. Check them out at www.elecraft.com. And by Autodesk, the makers of Eagle PCB design tools, the software we use to design all of our Workbench build projects. For more info and your free copy of Eagle, go to www.autodesk.com/Eagle today.
Welcome to the Ham Radio 360 Workbench podcast, your bi-weekly deep dive into making and technical topics of interest to the amateur radio operator. Good evening, George.
Hey, Jeremy. How are you?
I am well. And joining us again tonight, our friend and special guest, Smitty, KR6ZY.
Cheers, everyone. How you doing?
Hey, Smitty. Very good.
All right. So this week, Smitty is back. I kind of feel bad about this. We have a lot to talk about tonight around the BitX40, which, of course, was going to be our summer project. And what's ironic about this is, George, what's the date today?
Today is September the 22nd.
And Smitty, what is September the 22nd?
Well, if I go over to this shelf over here and grab my almanac, and if I flip through, those are the pages flipping, and I look at September 22nd, by golly, today is the first day of fall.
So the BitX40 was a complete and utter failure as a summer project for Workbench listeners. That's not fair.
You don't know how many people built the thing, and we just don't know. Could have been several.
Well, you have at least one, because I've done a lot of building on mine. It's not done, but it is usable, and I have made contacts on it.
Well, rumor has it you've also made a bunch of mods to it, too, right?
I have made a lot of mods to it.
And that's what we're going to be deep diving into a little bit later. Now, I have to say one thing. I shared this on Twitter a couple weeks ago, but last week I came home from work on a Thursday, and sitting on my doorstep was a yellow DHL bag. And the reason this is significant is because when we announced this way back in June? End of May, June. I never got around to ordering my BitX40. And so, yeah, worst host ever.
Where are you going?
So
how did you come to have one then?
Because
assuming that's what's in your DHL bag.
That it was in fact what is in my DHL bag. I actually have it sitting here right next to me on my desk, and because of the kindness of three friends of the show and listeners, one of whom being Smitty, the other being Kenneth, and the last one being Nick, these gentlemen conspired while they were together at what do you guys call it? What event were you at?
The E-Flea or the Dianza Flea Market, or I don't know. Is there a more proper term for it, George?
Foothill Flea Market.
Oh, see, now you're going all old school on us.
Oh,
it's not a Foothill for over a decade.
Well, I haven't been to it in over a decade, so.
Oh, well, fair enough.
So it used to be a Foothill
Flea Market when I was growing up there. Yeah.
Yeah. What was it like before there was indoor plumbing?
Actually, you'd have to go out and your feet would get cold every time you have to use the bathroom. So
where's the thing now?
It's at Dianza College. It's in the parking lot on the corner of Stevens Creek and Mumble, the street
85.
No, it's on the other side of Dianza. That's the name of the street there. I can't remember. Anyway, it's at Dianza College,
which is very close to Foothill. So
it is
very good.
Well, by Jeremy's standards anyway, because he's all the way on the other side of the country.
Yes.
But it's actually probably 15 miles away. But it doesn't matter. They're not that far apart, and it is the same flea market, and it is awesome.
And it was at a meal either prior to or shortly thereafter. Again, they conspired. They placed an order. And what's funny is they sent me a picture of the three of them together. And the caption was, "This is what happens when we get together." I had somehow completely missed that Smitty had sent the screenshot of the order. And it wasn't until a couple days later, we were shooting emails back and forth. And he's like, "We ordered you one, right?" And he sent me the screenshot again. And I was just dumbfounded. So I very much... Smitty, I really, really, really again want to thank you, Kenneth, and Nick for doing that. I very much look forward to building it, and honestly have not assembled it yet because I'm really excited to talk about some of these mods and the opportunities that are out there.
Well, you're very welcome. It was a kind of spur of the moment over breakfast at Hobie's kind of thing. We're all just sitting there. We're like, man, Jeremy still hasn't gotten it. Well, I don't know his address, or I've got a P.O. box that he said wasn't current. And Kenneth said, "Wait a minute, I've shipped something to Jeremy." And he looked through his email and found your shipping address, and we had it, and we're like, all right, we're doing it right now. And we went on the site and got you ordered.
Well, that was, again, very much appreciated. I want to thank you. Kale has said this a million times, but we really do have the best listeners. Now, speaking of Kale, George...
Yeah, speaking of Kale, there is some big news we had this last week, and Kale mentioned this on the Ham Radio 360 show last Tuesday. And the big news is that Kale is taking a break from the show.
A well-deserved vacation.
Indeed. And he's been producing the Ham Radio 360 show for, 80-plus episodes and over 3 years, every 2 weeks. And,
sorry, I was picturing you go 80 some years.
Yeah, I thought that's where you were going to go.
That's where my brain went. Sorry,
I did say episodes, didn't I?
Yes,
you did. Yes, you did.
Thank you. So anyway, after 80 odd episodes, and they've been pretty odd too, he decided to take a break, and I don't blame him because that's a lot of work. As we all know, it's a lot of work to produce a show, and he does it all by himself. So he has to record the interviews and edit them down and post them and everything. So it's quite a bit of work there. And he's got a big family and lots of things to do. So he's going to take a short hiatus, a vacation of 3 months. And I think one of the things he really wanted to do, as he mentioned on the show, was to get some time for him to play ham radio instead of talking about it. And I can kind of appreciate that. I could see where he'd want to do that. So he's going to go off and do that for 3 months, and he'll be back in January and pick up where he left off. So we're looking forward to him coming back. So if you're sitting here thinking, well, I only like listening to the Ham Radio 360 podcast, why would I listen to this Workbench stuff? Please don't unsubscribe. So keep it right here. We're going to keep the 360 Workbench in the feed like it is now. And so you'll be able to continue to get that show and John's show, the Field Radio podcast, which will come out the same week that Kale's normal show would have been out. So you'll still get both of those two shows, just not the main HR 360 for a few months.
And there may be a surprise later this year, but I shouldn't say anything and spoil it.
Well, you can't leave it at that.
Well, I am going to totally leave it at that. I'll share with you guys a fun fact that the show is actually about a month older than you realize it is. So
why is that?
Well, so I'm going back. The very first episode is technically posted June 17th, 2014, which would make the Ham Radio 360 3 years and 4-ish months old. But what's funny is when the show very first started, there was, the very first thing was a telephone interview with, I think its name is Cecil Higgins, AC0HA, talking about the Aries role in the Joplin tornadoes that happened several years ago. And of course, this was a very large nationally publicized disaster. So they had a fantastic conversation. And Kale later, when he went to go do the very first episode, found out that there was a problem with the recording. And so he had to do it again.
Oh, no kidding. So the one that was posted was actually the
second one. Yep.
Oh, wow.
So there's a fun Ham Radio 360 fact for you.
Fun facts.
Yeah. So again, Kale, enjoy your time off. We will be here keeping things running and look forward to your return. Now,
absolutely.
Now, speaking of things that we are doing. In addition to this podcast, we actually tried something brand new, at least brand new for me and George. And honestly, a lot of this was inspired because of Smitty. So for those of you who don't know, Smitty has a YouTube channel called
Smitty Working on Something, because it's usually me working on something.
So
it's not a very original name.
But in these videos, he basically gets on YouTube. He live streams him working on a project, and it generally involves either designing or schematic capture, board layout. And one of the things that I really appreciated about either participating or watching these is that the commentary is very good. I mean, honestly, my role in all of this...
Peanut gallery is strong.
Yes. Well, I was going to say my role in these previously has been there to heckle.
Yes.
But along the way, he sent me a text one day, and he's like, "Hey, do you want to join me on the stream?" I said, "Sure." So I stopped and bought a webcam. Well, we've had these webcams. As I had mentioned in the previous episode, I've been working on this MIDI mute button, and it was time for me to actually do the board design. And honestly, I was a little intimidated. And so I told George, or I asked George last Friday, I was like, "Hey, let's get on and do a live stream of you walking me through mentoring me on using Eagle to do my very first ever board layout." And so we set up a live stream, and I'll make sure to put a link in the show notes so that you guys can go watch this, because it was captured and posted on YouTube. About, I don't know, maybe half an hour into it, Smitty and Kenneth were both watching, and so we brought them in also. And so it was it's a 4.5 hour long video. And there's probably a good at least 15 or 20 minutes of actual content in there.
I want to quickly point out, it took 4.5 hours to capture, place, and route an 8-component circuit board. Now, that's not typical. I stress to add.
I mean, it's, it was his first time. I mean, yeah, not typical.
Well, it was 4.5 hours because there were 4 cooks in the kitchen, all talking about how to boil an egg.
I was about to say, I mean, some of the things I certainly recommend that you at least check it out and click through it. If you have the wherewithal to actually watch all 4.5 hours, that's great. And then the sad thing is after we stopped the streaming, we realized we forgot the most important part, which was going through the process to prepare the design to submit to have it fabricated. But we will cover that in another shorter, more topical video in the future. But I mean, overall, it was interesting because it allowed me to understand some of the mistakes that I had made, of things that I quote unquote figured out myself. But honestly, the biggest thing that this did for me is it built my confidence to realize that while board design was really intimidating, it's like anything else. Once you understand how to use the tools, you kind of understand the nomenclature. You understand the whys. It wasn't as bad as I thought it would be. Like it really is one of the things that I don't know, George, I think maybe we have an opportunity to actually try to produce some much simpler, much shorter tutorials. But I mean, again, the feeling of accomplishment that I have of the fact that board layout is now within reach for me. Like, I can't wait to figure out what project number 2 is going to be and tackle it.
Well,
it's a good feeling, isn't it?
And I'll add to that you knew what you wanted to do. It was just a matter of familiarizing yourself with some of the commands and some of the shortcuts, and also some PC board tips. So I sort of jokingly said it took 4 hours because 4 of us were trying to do it, but you got a lot of input from everybody, which is great. And not all the input necessarily jived. So you got some different points of view on some things, which I think is really helpful. Then you'll understand, well, what's kind of common conventional wisdom and what is like personal preference or tips that individuals have come up with.
Yeah, designing that first board though, there's nothing like it. That's got to be a great feeling. It's been so long since I've designed my first board, I can barely remember what that was, but I do remember what it was though. It was in college, and I just did a little. What was it? It's probably a power supply, because that's what everyone does is their first project in college. A little 317 based variable power supply. And just laying it out. Back then, we did it with stone chisels or something, but it was like laying out tape on top of the circuit board and then dipping the board into etchant. And this was in the early '90s, right? But it was But yeah, I made this and I pull it out of the bath and wash it out and solder components to it, and the thing worked. It was kind of neat. So
well, what's so cool about that is it's totally putting a tool in your tool belt, because as soon as you do that first board, like you're saying, Jeremy, you're thinking about, well, what would the next board be? The next board will be a breeze. I mean, because you'll know the steps, and you also have a handful of components that you've used that you're familiar with and how all that would work. And I did go back and sort of spot check through the video, and even though it was 4 hours long, it actually moved along pretty well. And one thing that I think was pretty good about it, a lot of times when you see how-to videos like how to use Eagle, it'll be pull out a component, put it down, route some traces, there's your board. And you kind of look at it and go, okay, I get that idea, but I had no idea what the commands were that they used or the options. Everything went so fast, I didn't really absorb it. And we went slow enough through the process and made enough changes that you can kind of really get the feel for how to do it. So I think it's actually a pretty decent video, considering it was just a live stream and no editing, and there you go.
Well, and as some bonus content in the beginning, as we were trying to kind of get set up, you also spent a good amount of time walking through the RF port switcher that you've been working on. So overall, though, I think the lesson learned was I think at our peak we had about 20 people watching. And one of the things that was really a treat for me at the end is everybody who was in the chat on YouTube and everybody who was willing to give their call sign. For this board, I actually added the call signs of all the folks who watched the live stream. So when it's manufactured, the call signs of the people that were there, are permanently captured in that. Because this is really just a cool thing. Again, I had a problem. I solved it with a prototype that I'm actually using right now on my desk. I have the prototype MIDI mute button right here. Captured the schematic in Eagle. We did the layout in Eagle, and now I have sent the design off to a fabricator here in the United States called Oshpark. Smitty, you want to say a few words about Oshpark?
I've been using them for years. I've never had, well, let me rephrase. Every time I've had problems with the board, they have been incredibly responsive. I think I've only ever had 2 boards that have had problems on them, and both times I was able to fix it myself, and I just called them or sent them an email and said, look, I just want to let you know in case it's a problem with your process, you guys can fix it. Don't worry about it. I've got it solved on my side. And they're like, oh my gosh, we'll refund your money and send you new boards. I'm like, okay, I didn't need that, but all right. So their customer service is fantastic. I have made so many boards from them, and the vast majority of them have come out perfect. They're just great. It's you upload either an Eagle or a KiCad file directly to them, and they will render it right there, show you what it looks like. And if their CAM process doesn't do exactly what you want, you can do your own CAM process, which is computer-aided manufacturing, where you take your board file and turn it into what are called Gerber files that they actually need to do the manufacturing. You can do it yourself or let them do it. But in the easy case, you literally upload the board file from Eagle or KiCad and give them a few bucks. I think it's $5 per square inch will get you 3 boards. So it ends up being $1.66 per square inch per board. And you get 3 or multiples of 3 if you need more. And they show up in 2 weeks. And if you need them faster than that, you can pay a little bit more money. If you need a whole lot of them, you can pay less money per square inch to do a medium run. I've done that several times, and I just love them as a service.
Yeah, and fairly decent information online to be able to use them. I placed that order, I guess technically last Saturday morning. I've already got notification that my boards have been accepted and added to another run. Because the way they work, and the reason why this is approachable is, Mark, do you know how big the frames are that they're printing, like the overall boards?
Yeah. Actually, I was just up there earlier this summer. They're about this big by about that big.
Oh, that's really helpple on a podcast.
Could you hold it up closer to the microphone?
Sorry, up to the microphone. Yes, I was doing it to the camera. No, they're, I don't know the exact dimensions, but they're probably 2 feet by 2.5 feet, full size panels. And yeah, what I'm sorry, Jeremy, I skipped this part. What they do is they aggregate orders from multiple customers. And so if you only need like a 1-inch or by 2-inch board, you don't want to go to a fab house that's going to charge you for this 2 by 2.5 foot panel, or roughly whatever it is. So what they do is they take all of these little orders and they kind of bin pack them into these panels, and they order 3 panels. And you have, 1 copy of your board on that panel, and they order 3 copies of the panels, and that's why you get your board in multiples of 3. And it's just kind of a way of cost sharing the process of making an entire large panel across all of these people that need little tiny things. I think the smallest circuit board I've ever made from them was 0.4 by 0.7 inches. It was a low noise voltage regulator that would retrofit into where an LM317 would go, or like a 7800 or 7800 series or 7900 series voltage regulators. And so it had like the 3 little pin holes sticking out the bottom, and then you had the low noise voltage regulator. So it was about the size of a TO220. And I ordered these, and it was, give us $2, and 2 weeks later, 3 of these little tiny boards show up in an envelope shipped. And I don't even know how they make their money on the little tiny boards, but I guess they make it up on the bigger boards. But yeah, great service. Been super happy with them.
Yeah, so I can't wait to get them. I'll probably throw a little video on Twitter or something when I get them. But again, it's so powerful that I had a problem. I designed a circuit. I'm manufacturing a board. When I get the board back, next step will be to design using Autodesk Fusion 360 a case that I will then 3D print for. And then, I will have literally built a gadget soup to nuts. And as a hobbyist for non-commercial purposes, all the software was free, and I've picked up some really amazing skills. Now, George, one of the things I think we should try to do, we'll add it to our incredibly long list of to-dos, is a lot of the tips that were given during the walking through all this with you guys last Friday. There's enough content there to maybe put together like an FAQ or a cheat sheet as far as spacing between traces, trace widths, via sizes, hole sizes, text, choosing fonts and stuff. Like there's a lot of, or a little guide of like what are the different layers on a board, since that seems to be kind of an industry standard. I think that's something we should try to work on.
I was thinking that there's a lot of topics like that would make for more good videos, and we could do some text write-up. But I think walking through that on video would be helpful. I learned something in this whole process, and Smitty, you've been doing this a lot longer, and this is really the first time I've looked at doing a video. But we've had a lot of listeners who've said from time to time, "Hey, would you please do a video?" So we'll talk about a project and wave our hands at the microphone and try to get you to imagine what this thing looks like. And Jeremy, you walking through this process really opened my eyes, because whenever I thought of doing a video for the podcast, I thought, well, boy, that's a lot of work. I've got to set up the cameras. I've got to do the thing, record it. I've got to then edit it all down and make it look really nice. And I just don't have the time to do that. And what I realized in the live stream that we did was we just turned on the camera and talked and showed graphics, and when it was done, and it was posted. And we didn't do any post-production. There is no editing. There is no, and it's very clear when you watch it.
Oh yeah.
But actually, I think it worked out really great, to the point that I would certainly like to do some more videos, maybe some more short things. I think the typical design techniques are great. I'm sure, like you have, Smitty, I've come up with a set of things that I always do when I design something, just kind of good design etiquette. And those are the kind of things that I think are worth sharing. So yeah, I think that's a great idea, Jeremy.
Well, for my next project, or at least the next need that I have that would require a custom board, is basically a 12 volt to 5 volt power supply to feed the 8 Pis I have in my Raspberry Pi cluster. That's just all one board that plugs into all 8 boards, and then just takes 12 volts instead of having this expensive and complicated and messy USB power supply. But no, I again, thank you guys very much for participating, because I told my wife, I was like, I never in a million years would have thought that this knowledge would have been unlocked or approachable, or it's not even the right word, but within grasp. And like, I really am just excited to come up with another project. I mean, honestly, there might be a good opportunity to redesign the power pole boards that we had at Dayton last year.
We could just take the holes off of them and it'll be fine.
Yeah, well, that video should only be 2 hours long then. So, George, other things that we've been meaning to do but haven't quite followed up with yet. Do you have an update on the winner of the PowerFilm solar panel?
Yeah, so the contest is over, and we had hundreds of people sign up. So thank you all very much for doing that. That was great. The turnout was really better than we had expected. And the folks from PowerFilm are going to pull a name out of the hat and give away that solar panel. We were hoping to do it on this show, but they weren't available to do it while we're recording here today. So they'll be on the show next week, or for the next episode. And at that time, we'll announce the winner. And the PowerFilm guys were really excited about working with us because there were so many people interested in their product, and there's a lot of questions about how it works and how big a one should I get and all that. So they're interested in coming on the show and talking a bit more about the technology. So I think we'll be hearing a lot more from them, and we should see them on the show in the next episode.
Well, that'll be good. All right. Well, we've talked a lot about projects. So speaking of projects, George, what's on your workbench this week?
Oh, I've got a bunch of things here I can run through pretty quick. The first thing I'd start with is that Barrick and I got together this week and talked about some build project ideas. And so we've been wanting him to do the antenna analyzer Rev 2 and wanted to get his thoughts on that. So we had a couple of ideas. One idea was to redesign the antenna analyzer board with an amplifier so we could use some more garden variety silicon diodes. But he doesn't really want to do that. So, the typical engineering process, once you've designed something, the last thing you want to do is do a revision of it. You want to move on to the next project. So what he wants to do is something a little bit different. So what he wants to do is come up with a new antenna analyzer idea, and rather than use that DDS module on the circuit board, he wants to use a SDR dongle and a broadband noise source and a directional coupler. So these are items that you could buy and just hook together, or perhaps we might make some boards to go with this to hook it all up properly. But the idea would be to use a SDR as a visual analyzer, like a spectrum analyzer, to see what the resonant frequency would be for the antenna. So the idea is if you generate a broadband noise source and you look at it on your receiver, then it'll just be noise across the whole spectrum. If you hook that coupler up to a tuned circuit like an antenna, then that tuned circuit will absorb enough energy so that you'll see on the spectral display of the SDR, you'll see a dip where the antenna is resonant. So it's a rather clever way of making an antenna analyzer out of some very common little modules. The other thing...
Well, real quickly, it is, but you know what you lose?
And what's that?
The ability to easily take that into the field.
Yes, and we very much talked about that. So we said, well, the downside of that is I can't just throw it in the toolkit and have it at field day. I need to have a laptop with the SDR dongle and all that. So that got to the third idea, which is we could take that exact same thing with the noise source and the SDR, come up with a little motherboard to fixture these things on, and put a Raspberry Pi and an LCD display on it. So we can go from a numerical display of the current antenna analyzer to a higher performance antenna analyzer, because the ADC performance in the SDR will be better than what we would have done with the DDS module. Is that enough three-letter acronyms, guys? I'm not sure if everybody's tracking this, but I just realized I was talking alphabet soup here. So the idea would be the next thing would be to talk about how you assemble these modules to do more of a PC-based analyzer, and then take that idea to an embedded version with a Raspberry Pi. So that's the current thought. Would love to get feedback from listeners. If you'd like to see one or the other of these ideas come to pass, let us know. So just send an email and let us know what you think about it. But that's where that lies at the moment. So Barrick has bought in to do a next generation analyzer. It's just a matter of exactly what form is that going to take. My guess is we probably won't have anything ready till after the first of the year, but that gives us about 3 months to get everything figured out.
And just to let folks know, if you do want to give us that feedback, you can send an email to workbench@hamradio360.com. You could also send tweets to me on Twitter at KF7IJZ or to George at KJ6VU. As you're talking about the Raspberry Pi option, I mean, we could, in theory, yes, design an actual hat that goes on there and make it single purpose, that you power it on and it automatically goes into a sweep. And then, of course, there are a lot of touchscreen options and things. The one thing about this is, first of all, if you were to use like an RTL SDR, the cool thing is you could actually, a lot of people say, hey, can I do this on 2 meters and 440? Technically, you get a little bit closer, certainly to be able to do 2 meters, maybe even 440 with the wideband noise source. But the HF side could become a little bit more difficult because while the RTL SDRs do have a direct sampling mode, I don't know what challenges you have from a signal perspective on HF with those.
Yeah, that's an issue, and I didn't bring it up, but that's an excellent point. So out of the chute, most of these SDR dongles start at 10 or 25 megahertz or something, so it kind of blows past half the HF band, which would make this useless. So I want to avoid having to have a block converter where you would have to add additional, up and down conversion to this, but rather see if we can do a direct sample. And so Barrick's homework assignment was to go figure out which RTL SDR would support such a direct sample approach that would allow us to get the whole HF band, at least 3 megs and up. So that's yeah. Go ahead.
I was going to say I have an RTL SDR dongle that has been modified to do direct sample, but at least for the one that I had, I was literally soldering like 34 gauge magnet wire onto these little tiny pins of the surface mount chip on the thing. I'm very glad I have my magnifier on a stick, on the big boom arm thing. So
the good news is you don't have to do that anymore, because you probably have a version 2 of the official RTL SDR blog. The one in the silver case. The version 3s actually have a direct sampling mode that is, I believe, software switchable.
Okay, but how do you still have to get the direct sample into it somehow?
Yes, the lines are already in place.
Oh, got it. Okay.
There's also modules that you can buy, little circuit boards, which do this. So you don't even have to design the board. So you can go on eBay and find for like $20, you can get a broadband noise source.
Yeah, I have one.
So
they're awesome.
So it may just be like, get that module, get the mini circuits directional coupler module, get the SDR dongle model XYZ, and some SMA connectors, and there you go. The rest is all software in the first incarnation of this, which would be fine for a benchtop thing. But to Jeremy's earlier point, it's not so hot for portable applications. So that's where we want to do something a little bit fancier. The other thing that's kind of nice about this approach is it's much more appropriate for doing things like filter design.
Yes.
So you're really
very good.
Yeah, you're kind of making like the poor man's spectrum analyzer and not quite tracking generator, but it would certainly make like Jeremy had mentioned building some bandpass filters in the switching matrix. Well, this would be a great way to tune them and test them, make sure they're working.
Actually, Smitty, you and I briefly talked about this. So, George, I'm going to guess you're going to give us an update on the antenna relay. And of course, when I saw that, like you said, I made this comment. When I originally had seen the QRP Labs kits from Hans Summers, I misunderstood because I thought that they were built as bandpass filters specifically for like the whisper portions of the bands. But Mark, you corrected me that they're full-blown HF bandpass filters for receive.
You're talking about Hans's bandpass filters? Yeah, they are. They're designed to be some number of megahertz wide. They're good for putting in front of a radio as pre-selection, but they are not like an IF narrow filter.
No, not at all. They're a wideband filter, but still. And honestly, those modules look pretty awesome, and they're very affordable to get whatever bands you want. And I don't know what kind of switching mechanism he has. I don't remember from our conversation about the Whisper kit.
So he does have a relay switching board that I remember seeing where you can take his bandpass filters and plug in like 4 or 5 of them, and then switch them in and out.
I have those for my Whisper broadcast, my Whisper beacon. So it's exactly what it is. It's a relay module that has 5 switchable low pass filters on it, and then the 6th is on the beacon itself on the Ultimate 3. And so you can do up to 6 bands on these. On that one, it's originally designed for a low pass filter because the output of the DDS on the Ultimate 3 is a square wave. So you need to excuse me, you need to filter off all of the harmonics. But the bandpass filters will fit on those modules as well. So I actually have 2 of the switcher modules, and then I've got low pass and bandpass filter modules for 80, 40, 20, and 10, I think are the 4 bands I chose that I'm intending to use to make my Bidex a multi-band Bidex. But we'll talk about that in a bit.
Ooh, cool. Very cool. So that's the thought on the antenna analyzer. So I think these are the ideas at this point. There's no decision made. And of course, listener feedback would be awesome. So we know what people would like to see and cross that over with what the engineer wants to do, which is probably what we'll come up with, and then go from there. Oh, you mentioned the coax relay. So while we're on projects, that project in the beginning of the video, as you mentioned, Jeremy, and while we're warming up in the beginning, I showed what that relay board looks like. The second version of the board was done and populated. I finished off the firmware and handed that to Barrick. So when we do our antenna shootout in a week, that'll be next weekend, that'll be all set to go. So he's integrating that into his Whisper control software for the antenna shootout. And once that's done, I'm going to do one last version of that board. And I think we'll make the boards available if anybody wants to build them as projects. So again, that's a 4-port, 4-to-1 relay antenna switching board that you could use to switch one radio to 4 antennas or one antenna to 4 radios. And somebody on the Facebook page had a great question. They said, well, can you do 4 antennas and 4 radios? And the answer is, if you have 2 of these boards, you just cross-couple the commons, and you can go 4 antennas to 4 radios, but only 1 pair at a time. And that's certainly possible. And the way the firmware and the software is written for it, you can control multiple boards from the PC. So I wrote a little PC program that you could use to control the board through a serial port. So anyway, that'll be a topic of more discussion. One thing Barrick is doing with that version 2 prototype board is he's putting it on a real VNA at work. So he's going to figure out what the S parameters look like and what if there's any undesirable coupling between the different ports and all that. So we'll get a pretty good frequency sweep of that switch. We'll see how well it works. Should be fine at HF. I can't imagine it wouldn't be okay at HF, but don't know about VHF, UHF. It wasn't really designed for that, but it'd probably work okay for that. So that project's moving along. And one last thing I wanted to mention here before we shift gears is at the end of this episode, there's a couple of on-air events that we recorded that we want to play. So we've caught the D-Star QSO party. Believe it or not, if you've never been on D-Star, there's actually an annual contest that happens on D-Star. And so we captured a few minutes of that so you can see what D-Star sounds like and people making contacts all over the world on the network. And also, if you remember back a couple of episodes back, we had Brian, W6BY, talking about the 10 gigahertz and up contests that happened in August and September. And this last weekend was round 2. It was the September version of the 10 gigahertz and up contest. And so I recorded some activities of coordination on the repeater network as different stations are setting up their microwave shots. So that's kind of fun to listen to. So we'll play both of those segments at the very end of the show if you want to stick around and listen to that. So, Jeremy, that's pretty much what I've got going on over here.
All right. Smitty, what about you? What's on your workbench?
Well, I've got several things on here. Kind of the one I've been spending the most time on is the Bidex 40, but we're going to get to that in a later part of the show, so I'm going to put that on hold for now. The other thing I've been spending a fair bit of my time on is working on a Hardware Hacking Village Learn to Solder kit that I'm running a Hardware Hacking Village for an event for my employer in the end of October. And so I was putting together a kit that will teach people how to solder. It's got, 7 resistors on it, 3 diodes, 3 capacitors, some header files, some little modules. It's got like an OLED display. It's got an ESP8266 microcontroller on it. It's got a little USB to serial adapter, a couple of WS2812 RGB LEDs. So it's got a kind of a smattering of lots of different things on it, and a couple of buttons. Anyway, so I was putting these kits together in a way that would be easy for people who have never soldered before to be able to kind of get their hands, I don't want to say get their hands dirty or get their hands burnt, but try doing some soldering for their first time. The company I work for is primarily a software company, or at least on the engineering side of it, and so we have a lot of people who know how to write code. But a lot of them kind of take the hardware that their code runs on for granted. And so I wanted to give them an opportunity to really kind of play with atoms as well as bits. And so it's a ESP8266, which is a little 32-bit microcontroller, very powerful. They've got a mega flash on them, which doesn't sound like a lot to those of us who are dealing with computers. But as far as microcontrollers go, a megabyte of flash is just ginormous space. And we have it programmed so that it is a little Wi-Fi scanner. So it listens to all of the access points nearby, and whenever it sees a access point, well, it will display on the OLED screen, little tiny OLED display, the 5 or 6, I can't remember exactly how many fit on the screen, but however many fit on the screen, strongest access points that it can hear, and it displays them with the SSID, what channel they're on, and what their signal strength is. And then it sleeps for 5 or 10 seconds, and then scans again and displays it on the screen. So you have this little constantly updating Wi-Fi scanner. We have a couple of other modes on there. There's one button that you can use to interact with the thing. So we have a couple of other modes on there. Like we have one called Pocket Rave, where it blinks the LEDs, the RGB LEDs into different colors, kind of a kind of thing. We have a flashlight on there, and then I have an Easter egg hidden in there. I took advantage of the large flash available on these things and managed to get something working on there that I'm not going to talk about until after the event. But excuse me, it is a what I think to be a very cool Easter egg, and I'm excited for people to find it and start playing around with it.
Now, one of the things, as I understand it, these ESP boards, a lot of functionality, built-in Wi-Fi, but kind of stingy on the inputs and outputs, right?
Yeah. Well, it depends on which module you get. Some of them have a lot of I/O. This one, I got the ESP01, which is the kind of the stingiest I/O. It's got 8 pins on the device. Power, ground, reset, and chip enable take 4 of the 8 pins. So you only have 4 GPIO pins, 2 of which are the serial port. Now, you can use those 2 serial port pins for other things if you kind of play the games right. So I've actually ended up sharing the serial port pin. Now, this is a TTL UART serial port, the kind of thing you would hook up to an FTDI chip to be able to program it. And so you still need that to work because this is how you get software onto the thing. But when you're not using it as a serial port, you can use those pins for other things. And so I actually have those pins doubling as an I2C bus, and that's how you talk to the OLED. So the OLED is on the same bus as the serial port that's used for programming it. And it just means that you can only do one at a time. You can't do both at the same time, but you can choose one or the other. And then the other 2 GPIO pins, one of them is the button input, and that button input doubles as the pin that you have to keep low when you turn the thing on so that you can program it. It's hand wavy. It's a button, and that's really all you can do on it. And then the other GPIO pin is the data out for the WS2812s. So the RGB LEDs, the serially addressable RGB LEDs. So I was able to make kind of this usable UI. I mean, you've got a single button, so there's a lot of, pressing quickly and long and hold press kind of UI elements in there, but it's got enough horsepower, and the 128 by 64 bit or pixel OLED display is big enough that you can actually get some good stuff going on in there. So it was kind of a fun project to see how much I could do with how little hardware.
Neat.
So I have a question for you. I've never programmed one of those parts, and I know they're super popular. So is there a SDK and a compiler for that family specifically, or is it using a generic compiler?
There is a GCC build chain for it. Mm-hmm. So, excuse me, I'm fighting a little throat tickle. There is a GCC build chain for it, and they have Arduino. It's all I do all of my microcontroller development in the Arduino IDE. It is not the best IDE. It is not the most powerful development environment. But given that most of the stuff I do for Arduino is either very simple and or meant for other people to hack on after the fact, I want to keep it in a simple build environment. ESP8266 has very good Arduino support. So I do everything in there, which means you're basically writing C and C++ code.
So you can just go into the Arduino IDE and put in a board support package for that device. Yep. Oh,
you do have to add the you have to add the ESP8266 board support into the board manager. So you have to paste in a URL into the board manager list, and then from there it just shows up in the list of boards, and you can add them and select it and say I've got a generic ESP8266 module, and it just programs it right over.
All right, so sorry. So hold on, graybeards.
What is it, Podwan?
Well, in this particular aspect, I'm not a Podwan, but for those of our listeners who stopped listening 15 minutes ago between the 3-letter acronyms and the DDS and the ESP and the 01 and the 8266. So an IDE is a 3-letter acronym for an integrated development environment. And what this is a tool that allows you to edit your source code. And in the case of microcontrollers like an Arduino or a PIC, it allows you to compile your source code for a target platform, such as like an Arduino that's based on a 328, or sorry, a 328, whatever you guys call it. There are 3 numbers in a row, so sue me.
No. 328 is what most people would call it, the 328, except for the fact that I know it's 32K of flash and 8K of RAM.
Yeah.
And so I always think of it as the 32.8, not the 328.
Yeah, I seem to recall in the live stream I got a lambasting about this. Regardless, but anyway, it's a free tool that you can download, and it the Arduino one is very, very bare bones. It doesn't even do syntax checking, meaning are you typing things that make sense in the language. It doesn't do any type ahead, meaning that it can auto-complete stuff for you. I mean, it handles indentation really well, and it handles curly braces really well, but I mean, otherwise it's fairly bare bones. Now, again, links in the show notes as far as the library software and the IDE, and a couple links, because just looking at this, Smitty, what's really cool, this little ESP board, it looks like it's $7.
You get them in bulk, and they're about $2. You buy them 100 at a time.
Shipped from China for $2, and it's overnighted.
Yeah. Well, no, it took a week and a half to get here, but yes.
Hey, by the way, one thing you mentioned, a downside to these things, Jeremy, is you said, well, they're really pin constrained, and I know there's different versions with different numbers of pins and all that. But Mark said something really important. One thing really important, which was only one, that he's using the I2C interface to talk to the OLED display, and the I2C bus, as we've mentioned in previous shows, it's a bidirectional bus that allows you to hang multiple peripheral chips on that 2 pair of wires. So if you said, well, I want to have my OLED display, plus I want a temperature sensor, and I want to have an I/O expander to control 8 relays, and et cetera, you could just keep dropping those chips on that pair of wires, that clock and data pair, and you can expand it as much as you want. So even though it's physically constrained with only a few pins, you can actually leverage those serial buses really well. That's the whole point of them.
Hey, Mark.
And they make a I2C to GPIO chip as well, several of them. So if you really need individual controlled GPIO pins, you can still hang those off of an I2C bus.
So what's the difference between an ESP8266 and an ESP32?
The ESP32 is a newer version of it. It's by the same company. It includes Bluetooth, and there are some other advantages. I don't remember exactly what they are. But the real answer is that the ESP32 is more expensive, which means I am unlikely to use it in this particular context until I need some of the new features.
Are you saying it might be $3 a piece?
Yeah, something. Maybe $3.25. Yeah. So I have not actually played with the ESP32 yet, but it is the new hotness from Espressif.
ESP32 development board, $12. ESP32, they're same thing, $7. So it looks like they're pretty inexpensive. Just looking at pricing at eBay.
Yeah, I mean that's. I know Adafruit has a couple of different footprints, and SparkFun have a couple of different footprints with this chip on it. But I mean, it's cheaper than like a stock Uno from Arduino, which is what, like $20-$25 for the branded Uno.
Yeah, but I stopped buying the large Arduino kits. I've moved on past the Atmel at this point. Most of my new projects, if I need a small thing, I'll probably end up using these ESPs because they're tiny and cheap. But for my new projects that go forward that need a lot of power, I'll be using probably like a Teensy 3.2.
You know, I noticed tonight, so I was a Micro Center earlier, and of course, Micro Center is like my favorite store, both from a computer stuff and as well as the de facto new destination for components, a lot of Adafruit products, a lot of things from MCM Electronics. And they have actually a very large, comparatively for the section, they had a very large Teensy section. You want to tell us what a Teensy is?
So a Teensy is a microcontroller that is roughly the same physical form factor as the Pro Micro that you guys use on the antenna analyzer and the Smarty Load, and that I have used on several projects as well. But it is a ARM Cortex M4 chip, or maybe it's an M3.
No, it's an M4.
I can't remember which one. It's an M4. Mm-hmm. So it runs at like 180 megahertz. It's got gobs and gobs of I/O and RAM and flash and everything built onto it. It's got a built-in real-time clock if you give it the proper crystal for it. I don't think the 3.2 has the floating point and DSP commands in it. So I think it's just the M4, not the M4F. But it is just got gobs and gobs and gobs of CPU and whatnot. And the satellite optimized amateur radio project that I started back around Maker Faire, I kind of got a prototype ready for Maker Faire and then haven't really done much with since then. I'm just waiting for various things, but one of the next things I'm going to do is upgrade it to a Teensy that will have enough horsepower to be able to do, I'm hoping to do some like software DSP work. Eventually, be able to generate some packet commands and maybe packet packets, AX25 stuff, send and receive packet radio on the SOAR itself, and some other things. Anyway, I'm rambling. Sorry.
Hey, by the way, I have a topic for a future discussion. You just touched on packet, and I've got an application for doing some packet radio stuff. And I've started looking into it recently, and I would love to build some packet gear. And it's kind of funny that packet radio hasn't changed in 30 years, but it's still useful. It is not. So I'll hit the pause button on that one at the moment, but I'd love to chat with you about that. That would be a good topic for a future show.
Cool.
We could probably get Kenneth in on that. I think he knows a thing or two about packet.
Yeah, just a little bit. He might have an opinion.
Yeah, you're gonna rock the technology like it's 1985.
Exactly. Well, it was a great idea back then. It's still a good idea. And frankly, the only reason things aren't faster is because the radios they run over are conventional 5 kilohertz narrowband FM radios. So that's the limiter.
No, we'd be able to squeeze more data across those radios if we were allowed to. The FCC limits symbol rate. That's our ultimate limiting factor at this point.
Well, isn't there a proposal to change that?
On the HF bands, I don't know if that applies to VHF and UHF. It might. But yeah, the proposal that the ARRL was making, I think they're the ones championing it. The proposal is to limit it to bandwidth instead of symbol rate. Symbol rate made more sense when your only digital mode was RTTY, and symbol rate directly applied to bandwidth. And they're like, all right, well, don't do any faster than this symbol rate, and you won't go wider than this bandwidth. But nowadays, it doesn't make nearly as much sense.
Okay, so good topics for the future. So
awesome.
Is there anything else on your bench? Well, as we loop back to what's on your bench topic?
I don't want to take too much time. I've got a bedside clock project that was a kind of a 7-segment LED display out of WS2812s that I made some mistakes on the first version of the controller board. I want to go back and fix that up. And then this is one that I just started talking to a friend of mine about at lunch today. I'm trying to think of what I want to do for my next Learn to Solder kit. And one of the things that I like to do with my Learn to Solder kits is make sure that the thing you end up with at the end of your time at the table is something that you can actually use. Not just like a Larson scanner or, hey, look, the LEDs go blink, blink, something that's actually functional. And so, the one that I just described, it's a Wi-Fi scanner, and you can use it to figure out what access points are nearby. And that's kind of neat. And there's also a little game on there, kind of a, we call it Super Pecky Run, but it's this like little character jumping over boxes that are being thrown at you. But anyway, and so the next one I had an idea was a friend of mine works at Underwriter Labs, UL. And he does a lot of work with random numbers and analyzing random numbers and figuring out just how random your random numbers actually are. And we went to lunch today and had some very exciting conversations, I'm sure, as people are like, their heads are hitting the table and as they're falling asleep listening to us at the restaurant. Anyway, and we were talking about hardware random number generators and what it would take to make an actual real honest to goodness hardware random number generator, not a pseudo random number generator, but something that can actually demonstratively show physical entropy and turn that into something that the computer can use. And it's actually not that hard to do in hardware. And I would excuse me. So I'm kind of thinking about designing a real honest to goodness hardware based random number generator in discrete components with like a reverse biased transistor. And then to run it off of a low voltage, you need a high voltage to reverse bias high enough to get into breakdown, blah, 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 blah. So there would be like a step voltage ladder thing. I can't remember exactly what it's called. A bunch of capacitors and diodes configured such that when you clock a signal across it, it generates a high voltage out the other side. And then feed the output of the reverse bias transistor into an analog input on the microcontroller and read the noise that's coming off of this thing, and then hash it and whiten it and blah, 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 and then feed that out to a computer so you can actually seed your random number generator in the kernel, seed the random pool in the kernel with actual hardware random numbers. It's not really functional, but it would be kind of a neat way of showing how this stuff works, and you can still do it with discrete components, individual transistors and resistors and capacitors and diodes. And if you lay the circuit board out right, you can actually demonstrate how the stuff works as they are soldering everything together. And I don't know, that seems neat to me.
Funny you bring this up, because I've always wondered, technically I've heard it said before earlier in my education that when you tuned an analog television to a channel that was static, you were literally receiving the entropy of the universe. And I've always wondered
Correct.
about, generic over the air static's the wrong word, but generic receiver static to be used as a hardware random generator seeder.
So the problem with trying to do something like that is that it is too influenceable. If I go outside your house with your TV turned to a dead channel, and I am picturing the opening lines of Neuromancer here, the sky was the color of a TV tuned to a dead channel. Anyway, if I go up to the outside of your house where you're using your TV tuned to a dead channel and receiving the static and sampling that and using that as your random number source, it's very easy for me to turn on a transmitter and make that static no longer random. and actually influence what you're doing. So you need to be careful about trying to use something like radio, because it's way too easy to influence from the outside.
That makes perfect sense.
So there's kind of one of the jokes is that one of the best random number generators you can do is to point a camera at a lava lamp and then hash the values coming from your webcam. And it turns out that the lava lamp generating kind of unpredictable color shifts as the bubbles move around and whatnot is not actually where the noise is coming from. The noise, you would have a better random number generator if you literally put a piece of plastic in front of your camera or like painted it over so that it had no visibility from the outside whatsoever, and you were just using the thermal noise of the CCD camera. That's actually not an uncommon way of generating random noise.
Although it's interesting, I would assume you would have the potential to influence that as well by applying heat, but the long and short of it is that
all that does is increase and decrease the amount of noise that you're getting. It doesn't actually let you influence what the noise is.
Yeah, we're giant nerds.
Hey, do you think anybody's still listening at this point?
Yeah, no kidding.
Well, we
can edit this out in post, right?
Yeah, we're not going to, because this stuff is fascinating, but so Jeremy, what's on your workbench? Well, Jeremy, I'm glad you asked. Honestly, this week there's really not a whole lot project or radio related. I'm just I've been collecting the parts to build the hardware MIDI mute buttons, and as I mentioned in the live stream, since George and I have the same mixer, I'm going to assemble him one and send it his way. Started very preliminary design on the case, because the board I ended up building is 2 inches by 2.5 inches. And when I show pictures of this, it'll make sense why it had to be that large, so that the cables, it's powered by via USB, and then there's a MIDI jack, and I wanted both those cables to come out the same end of the case, so you didn't have some weirdness where like the USB cable came out one side and the MIDI came out the other side, and just took up a lot of space. So started preliminary design on that. Actually, George or Smitty, how thick are these boards?
This standard board thickness, if you just order the default, is 0.0625 inches typically.
Okay.
But when you order the board
calipers.
But when you order the boards, you can usually specify various thicknesses depending on what you're making, but 0.625 is typical.
Okay.
So I just measured mine at 1.7 millimeters because I had it on the wrong side. So that is pretty typical, and that is what you will get from Osh Park as well.
Okay.
Osh Park does have 2 different size boards. They have this one with 1-inch copper, and then they have one that is half as thick of the board, but with twice the copper, which seems like a weird combination to me, to have half the thickness of the board, but twice the thickness of the copper.
Yeah, that does seem a little counterintuitive. But I mean, that's only going from 1 ounce to 2 ounce copper. So, that's thing one. Have actually recently cleaned up my workbench and finally installed the Regal, the linear benchtop power supply that I bought from tequipment.net while we were at Dayton. Finally got that on my workbench. What's hilarious is that thing has been serving as random power supply for gadgets. It has done everything from power the Tinkerboard to running a little tiny radio that I had picked up at Dayton. That's this cute little like 20 watt VHF UHF radio. It is not RF proof. As I have found out, if you key up with 5 watts in the room, it will restart and then throw fault conditions. The good news is it doesn't reset its settings. So when it comes back up, it's still on the voltage and current limiting that you set it in. Honestly, the only other thing that I've really been into this week is something that I really came out of nowhere as a recommendation from a coworker.
What's that?
Well, so this is not even remotely ham radio related. However, it is RF related. So you guys are familiar with the term cord cutter, somebody who does not pay for cable or satellite television.
Mm-hmm. Yep, I am one.
So I have I've been a cord cutter since long before the phrase cord cutter was minted. For all intents and purposes, it would have been about 2006. It was somewhere around or shortly after The Sopranos ended, and I don't remember what year that was. Is when I got rid of cable television. A couple years later, Netflix streaming started becoming viable. So I have a few services like Netflix and Hulu, Amazon Video, and but one of the things that I miss is I just sometimes like to watch the local news. Just to watch the local news. And of course, there's a lot of good children's television on PBS, and we have two really good PBS stations. The one from Kentucky and the one from up in Dayton are just really good PBS networks, or whatever you want to call it. And I've had an antenna in the family room hooked up to the TV before. Which was fine. But then when it was time to get a new television, the TV I bought did not include an over-the-air. It didn't include a tuner at all. So there's no F connector on it whatsoever to be able to plug coax either from a cable box or from an over-the-air antenna into it. I had purchased this cheapo $13, ATSC decoder that was basically a tuner that you could plug into an HDMI port. It had a USB port and an SD card slot, so you could use it as a very low fidelity DVR. But I mean, I had it replaced a couple of times, and to get it to work, you actually had to put a weight on the HDMI cable because I'm sure the connector wasn't soldered very well. Of course, now that I'm saying this, I actually have reflow equipment, so I could probably go fix it. But it's really a giant pain in the rear end. So a coworker of mine, he and I hadn't had a chance to really talk about hobby stuff. He also he's not a ham, but he is a tinkerer and has built a lot of cool stuff with Raspberry Pis and Arduinos. He's built a lot of video game controllers, like arcade style video game controllers, custom out of different, wood and whatnot. But anyway, he told me that him and his wife are finally deciding to cut the cord, and that to handle the over-the-air part, because his house had an over-the-air antenna on it and already had all of the RG6 coax run from the outside of the house into the house and then distributed throughout the house. He bought this box that is basically an over-the-air RF television to IP bridge. So the box is called an HD Home Run. You plug one antenna into it. It has Wi-Fi built in, or it has an Ethernet jack that is a 10100 Ethernet jack. You apply power, and the basic model is $99. It has two tuners built inside of it, and then you can watch over-the-air television anywhere on your network, on your phone, on a tablet, on a desktop computer, on an Apple TV, Chromecast, you name it, and you can then basically stream over-the-air television to anywhere on your network. And that sounds silly, but it's very much in line with what I've done with, sticking the Air Spies on a little host, and I can now stream RF reception anywhere in the house as well. So I just thought it was really cool, because it's now on the second story of the house, I get 15 new channels that I couldn't get from the first floor, and I'm just very happy about that.
That's really cool. I've been a cord cutter for close to 2 decades now. It was the late 90s when my college roommate moved out, and right before my then girlfriend, now wife, moved in, I think is when we stopped paying for cable. And to be perfectly frank, I haven't really missed it much. Getting like Amazon Prime and Netflix and all that has made that a heck of a lot easier to do. But we watch a lot of movies on, then VHS and DVD and now Blu-ray. But yeah, I've never been a huge fan of cable. So no. I strongly encourage this.
I mean, the long and short of it is we don't really have a chance. We don't really have a lot of time to watch television to begin with. And years ago, I just decided I would rather spend my time doing something that enriches me rather than staring at the television. And granted, I have shows I like, but TV is not a priority. The other thing is that this box can integrate with the Plex or Kodi media servers. And if you pay for the Plex subscription, you actually get DVR functionality built in. So it has been a real treat I've started recording old episodes of This Old House and The Woodwright Shop and The Woodsmith. it's really cool. They have a version that will work with a either unencrypted cable or from the wall, or if you have a cable card available from your cable provider. And then they also have a version that has a built-in H.264 video encoder, which basically that compresses the video stream down to 1/4 what it comes out of the $99 box, which if you're DVRing a ton of stuff, Plex will do some transcoding from the original one, but it's not as efficient as the hardware H.264 encoding out of the HD Home Run Extend.
You guys are so much more video literate than I am.
I mean, again, I never even realized this class of device existed until my friend at work mentioned to me, and I don't know. It's just nice. I mean,
sounds useful.
I got to watch the news tonight.
I find there are so many channels, and I just don't have that much time. Kind of like you were saying, my video viewing is pretty simplistic. There's like 2 programs that I would watch. They're already on TiVo. I don't ever watch anything live except maybe the news, and I find most of that stuff I just stream off the computer. So. Yeah, I just don't have. I don't say this with any great relish. I just don't spend much time on the TV, like you were saying.
Same here.
There is one event a year that I'll put must in quotes. It's a very first world kind of must, but one event a year that I really want to watch live, and that is the Indianapolis 500 race.
Yes,
it's something that my mom and I every year when I was growing up, my mom and I would ditch out from our Sunday morning obligations and watch the Indy 500, and it's a race I really enjoy, and it's live, and I don't have a way of watching it at home. So last couple of years there have been ways of streaming it, and that has worked out pretty well. But
I say it's a big tradition in my wife's side of the family. I also enjoy. Have you ever been?
No, my mom was in Indianapolis for the 75th year, but she was there the week before the race. She was there for like a training event. So she went to the Speedway and watched some of the qualifying runs, but she was not there for the race itself.
I had the opportunity to go. So there's a national competition called Science Olympiad that happens in middle and high schools. That's a really awesome, multifaceted science competition between schools. And nationals, my freshman year of high school, which my team made, was at in Bloomington at the IU at Indiana University, and this happened to be going on like the 2 days before the race when they're doing like time trials and test laps and stuff. And so nice. We got to go as special guests and actually get to meet a lot of pit crew people and drivers and engineers, and it was actually really awesome. We're going to go ahead and take a break, and when we come back, we are going to jump into the BitX40 topic. We are going to find out what Smitty's been doing with his BitX40s, and he does have multiples. He has one of the original ones with the analog tuner and one of the new ones with the Raduino tuner. Smitty has done a ton of mods that are all available and well documented online. You heard him mention earlier he's got bandpass filters for multiple bands, which may imply that his radio may be a little more frequency agile than most people's, and I can't wait to hear about that when we come back.
Elecraft is one of my top picks for high-performance HF radios. They make fantastic base station style radios, amplifiers, pan adapters, and other station accessories. They're also the designers of the KX3 and KX2, the ultimate portable HF radios. If you're thinking about SOTA, portable operating, or travel, you really need to be looking at Elecraft. Elecraft has some of the best designs in the industry, compact, high-performance, feature-rich designs. You're really going to love them. And Kale just got his KX2. So be checking out the Ham Radio 360 podcast and also the Facebook page and see what he's doing with his KX2 radio. The KX2 is my personal favorite for going portable. It's ultra small, 80 through 10 meters, sideband CW and data modes, and the thing runs 10 watts on the internal batteries. You'll love it. Check it out at elecraft.com.
So several months ago, we introduced to folks the BitX40 radio project, made and sold all the way over in India, designed by a gentleman named Asher Farhan. And tonight we're going to talk to Smitty about his adventures, because he really picked up and ran with this, especially here recently. He talked to us last time introducing the radio and has come back now with a bunch of modifications and adjustments and some actual hands-on experience using the thing. So, Smitty, just real quickly, at a high level, remind us what the BitX40 is.
Sure. So the BitX40 is it's a kit, and I will put kit in quotes. It's not a kit in the conventional sense where you've got a board with a whole bunch of parts that you need to solder on. The board itself comes completely pre-assembled, but you still have to put on the knobs and the buttons and the switches and connect power to it and things like that. But what it is a 40-meter QRP single sideband radio. The dual conversion, so it is a heterodyne, not a super heterodyne. I'm trying to remember the terms here, but it's a radio that is very hackable. And it's very easy to understand how the radio works. You can actually look at the circuit board and say, oh, I can see the traces of, here's a block of amplifiers, then here is the crystal filter, and here is the whatever, right? And you can visually understand how the radio works. And the best part about all of it is that it's $60, $59 shipped from India for this kit. And the kit technically has everything you need to get it up on the air, but you'll have a board with a bunch of wires and knobs and things hanging off of it. So it's a little bit better. Your adventure doesn't end there once you have it up and running. A lot of people are working on case designs and modifying existing cases to put them in there and fun things like that. But it's a little 40-meter radio. It is controlled. The current versions are controlled by what's called the Radduino, which is an Arduino-based radio controller. It has a SI5351, which is one of those DDS chips that we were talking about. It stands for Direct Digital Synthesis. Basically, it's a chip that you talk to it over a serial port on one side, and a microcontroller says, output a signal at 12 megahertz on this pin. And the DDS chip does exactly that. You can give it exactly what frequency you want, and it will output that signal, a signal with that frequency on it. And you need these kinds of oscillators in a radio design. And so the Radduino is capable of generating 3 of them. By default, it only needs 1 for the Arduino, but I have mine modified to use 2 of them. So, does that answer your question?
It does. And as a reminder, during the last episode, you actually did a really great intro to the BitX40 video. And if folks haven't checked that out, I will make sure that we put a link to that video on your YouTube channel in the show notes.
Cool. Thank you.
So, okay, 40-meter radio QRP, about 7 watts, voice only, lower sideband only.
Stock, yes.
Yeah, well, that's what I'm talking about. It's just out of the box.
Gotcha.
You've got
out of the box.
The little electret hooked up to it, the volume and all of that. But we didn't want to leave it there. So since we have last spoken, where have you gone with this?
Oh my gosh. Okay, so the first thing I did is I got involved with the groups.io BitX20 group. Now it's a little confusing because the group is called the BitX20 group. Don't let that confuse you. They're talking about the BitX40, the old BitX20 kits, and the new one that he's actually working on called the Micro BitX. So it's kind of the Asher, all things Asher Farhan groups.io group. And so I got involved in that group, and that has been amazingly helpful to help me figure out what kinds of things people are doing with these radios. Excuse me. There's also a website called bitxhacks.blogspot.com, I think. We'll put a link to that in the show notes too. BitXHacks is run by Bill Mera, the Solder Smoke blog guy. And he posts a bunch of things that he finds there. But that kind of seems to have stopped being updated. But there were definitely some good hacks there. But I think most of the activity is going on in the BitX20 groups right now. And on there is a very active gentleman named Allard Munters. Allard Munters, and he is kind of the current developer of the BitX40 software. And if you look at the software that he's uploading, this is software that goes onto the Radduino. So it's Arduino code that goes into the Arduino Nano that's part of this Radduino. And in his documentation, he links to all of the hardware modifications that his software is there to support. So there are lots of things that people are adding to these. For example, one of the things that you can do is that if you change the frequency of the VFO is normally on the low side, so it's like 5 megahertz, and so let's see here, we're trying to do 40 meters, which is 7 megahertz in, right? And so if you mix that with 5 megahertz, the sum of that is 12 megahertz, and that's where the IF filter is. And then the BFO takes it from 12 megahertz down to audio. But if instead of generating your VFO at 5 megahertz to add to the 7 megahertz to get into the IF, if instead you do, it's 19 megahertz, then you end up subtracting 7 megahertz from the 19 to get to the 12 megahertz that is your IF. And so instead of adding it, you are now subtracting it, which means you're flipping the sideband. So basically, by moving the VFO from 5 megahertz to 19 megahertz, you change it from a lower sideband rig to an upper sideband rig, which for sideband, if you're talking voice, isn't very useful on 40 meters.
No.
But the convention for being able to do digital modes, like PSK31 and FT8 and JT65 and all of that, is to use upper sideband, even on 40 meters. So they've modified it that you can. They've modified the software so that you can do upper sideband and lower sideband on it.
Cool.
Although that does require a little bit of a modification because there's one place on the board that doesn't like having that high of a frequency on it. So you have to remove a couple of capacitors to improve the upper sideband performance.
So if you remove those capacitors, does it affect the stock lower sideband voice performance?
No. I looked at what those capacitors were, and I understood what their function was right before I removed them, and then I purged those brain cells to use them for something else, probably a Monty Python quote. But I can't remember exactly what those capacitors were there for.
Fair enough. So then,
but no, it does not affect. It still works as a lower sideband.
And then, if you want to use it as a digital mode radio at that point, so are you basically just replacing the microphone with a line in somehow?
Exactly. You hook it up to this radio just like you would hook it up to, your big Yaesu or Kenwood or ICOM HF rig. They make audio interface boards, and it's a speaker out from the radio and a microphone into the radio, just like it is on your big rig.
Cool.
Mm-hmm. So if we want to just talk about like all the kinds of mods that I made, let's see here. I just listed that one as an example, but that is one of the mods I've made. So I removed those two capacitors, and the software is now capable of driving this radio as either upper sideband or lower sideband. What else have I done? I'm looking through the list of notes that I made. So the software upgrade from Allard Munters is kind of the first recommended modification to make to these things. Even if you haven't made any hardware modifications, Allard's software does a lot of new features. It kind of the UI gets improved. It's a lot easier to use. And there are the tuning is a lot easier than Asher Farhan's stock software. So it's highly recommended that you upgrade to that. And then when you look at the README file for his software, it links off to a lot of the hardware modifications that you need to make. So like the upper sideband, lower sideband one. Let's see here. What's another one? Oh, modify it for CW. So without going into too much of the radio nitty gritty on how these radios work, there are kind of two conventional ways of using a single sideband radio on CW. And one way is to just generate an audio tone and then send it through the radio as a normal CW or sideband radio as normal. And you get this audio tone out the other side. And there are some advantages to that because it doesn't require any modifications to the radio. You can just, plug it into the front panel where the microphone goes like you would with any other digital signal. But it is more likely to get distorted. It has some other issues. It's not ideal. It's kind of not an ideal way of transmitting Morse code. So instead, one of the modifications that they've done here is at one of the mixers, I think it's the BFO mixer, there is a way to apply a DC voltage to one side of the ring mixer, and that takes it out of balance. So normally these things are balanced so that the carrier you're transmitting gets nulled out. The single sideband, the whole thing about single sideband is that you have, when you mix two signals together to get an AM signal, you have this big strong carrier right smack dab in the middle of your output, and then you have an upper sideband and a lower sideband. And the upper sideband and lower sidebands are redundant information. They are the same information, just mirror images of each other. And you've got this giant strong carrier in the middle that doesn't have any information. So the idea behind single sideband is to filter out one of the two sidebands and to cancel out that carrier so that you can put all of your energy, all of your transmit power into just what is needed to send your signal across the air. And that's the whole idea behind single sideband. Well, the way you get rid of that carrier is by having a very balanced mixer without any non-linearities in it. And the carrier just kind of magically goes away. And I'm waving my hands at the math and the electronics here. But the point is that a properly designed, balanced mixer will not have any carrier in it. However, if you intentionally go into that balanced mixer and say, yoink, and you add a whole bunch of DC voltage on one of the sides, then that takes it way out of balance and all of your carrier leaks right on through. Well, guess what? That carrier leaking right on through is what we want for a CW signal. So there is a very easy mod where you through a 10K ohm resistor, you pull down to ground, or maybe add up to VCC. I don't remember which, but you apply a strong DC voltage to one of the pins on this balanced mixer, and all of a sudden your carrier starts leaking through, and you can turn that on and off very quickly and use it as a very good, very efficient CW transmitter. So that's one of the modifications I've made. And once you have the ability to send a carrier through the radio, now the Radduino works as a keyer. So you can plug in just a straight key if you want. Some very recent versions of Allard's software actually has a keyer built in. So you give it, a dot and a dash like a normal paddle, and it does all of the iambic keying controls and everything, all within the Radduino. You do not need an external keyer.
Cool.
I thought that was a neat mod.
Yeah. I'm wondering if, is it, I can't remember the guy's call sign now, K3NV maybe, who did a really amazing CW machine basically based on Arduino. I wonder if it's using any of that code.
For transmitting or trying to decode?
Either.
Okay. So for transmitting, I don't think so. I think he said he wrote his own, because I remember him talking to Allard himself is not a hardcore CW user. So he was chatting with some of the hardcore CW users on the list, trying to tweak the feel of his code. So I don't think he's using anybody else's code to encode Morse code. And then there's also been discussion on the list about trying to decode Morse code on the Radduino, and the general consensus is that Morse code decoders don't really work all that well, and you're better off trying to learn, or if you really need a decoder, you can get external decoders. They are non-trivial to implement in software, and the microcontroller on the Radduino is already running out of code space. So there's been some reluctance to try and implement a CW decoder on the Radduino.
Gotcha.
What other modifications have I made? I'm looking at my radio right now. Oi, battery. Okay, that's heavy. So there are various other little things, like when you're doing Morse code, when the modification that I just told you about, where you pull one of the mixers way out of linear and have it leak the carrier through, that doesn't actually give what's called a side tone back to the user. The user can't hear his or her own signal. And so one of the pins, it comes out of the Arduino and gets mixed in with the headphones so that the Arduino can generate beeps to the user. And they end up using this for both UI elements as well as Morse code. So like when the thing powers on, you can hear it beep, and as you're going through and like doing the function settings and whatnot, it will beep to give you feedback as to what it is, what you're doing and whether it worked or not, that kind of stuff. So that needs to get mixed into the audio. Let's see here. What else? There are a bunch of buttons that Allard's software adds support for. There's really one that you need to implement, or you don't need to, but that is best to implement. That's called the function button. That awful lot of things happen with the function button, and it's literally just a DC contact closure to ground. You short this one pin coming out of the Arduino to ground through a button, and that's your function button. So it's super easy to add. There are two other buttons that he's using, one for calibration and one for spot frequencies. I haven't really played with them a whole lot. But yeah, so like on the front panel for mine right now, I've got a headphones connection, I got a microphone connection, I've got a keyer connection, and then I've got an external PTT connection that I'm not actually using because I have a button on the front panel for PTT. I just push the button on the radio box itself for PTT. And then I've got a tuning knob and a volume knob. The tuning works very similarly to Asher Farhan's original tuning, but he cleaned it up and it's a lot smoother to operate now. Asher's was kind of hard. It would jitter, like if you set the tuning knob to where you wanted it to be and then didn't touch it, it would still oscillate back and forth between immediately adjacent frequencies, and that was kind of made it very hard to use the radio.
Was this, you had mentioned in a conversation about instead of using something like a rotary encoder, it was using a standard potentiometer?
Correct. So the standard potentiometer is the one that comes with it is a 1-turn, not a 10-turn, is a 1-turn potentiometer. And through 80%, or maybe it's 60%, but through some large percentage of the rotation of the potentiometer is just a direct tuning knob. And it covers, I think, 50 kilohertz of RF bandwidth. But then when you get to the very low end, it starts going down by, I think, 10 kilohertz at a time. And so it kind of jogs over, through the band at a very fast pace. And then if you go up to the very top end of the tuning knob, it goes up by 10 kilohertz at a time. And so let's say you're down at the bottom of the band and you want to get up to the top of the band, you would just crank the knob all the way up and you'd hear it go click, 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 click as it's going up 10 kilohertz at a time. And then you get it to roughly where you want it to be and then tune it down from there. And then you've got a 50 kilohertz range that you can tune with the 80% of the tuning knob at that point. That makes sense?
Completely.
Okay. It is easier to use than it sounds by describing it. It is more intuitive once you actually put your hand on the knob and start using it. The problem is that you can't tune the entire 300 kilohertz of the 40 meter band with the knob. It just doesn't have high enough resolution. And so you need to only be able to tune a certain chunk of it at a time and then select which chunk you want to be able to tune. The other alternative, and Allard's code does support this, is if you have a 10-turn pot. So a pot that has 10 turns to it, so you can very, very, very precisely pick where in the full range of the potentiometer you are, then you can actually set it up so that the whole range of the tuning knob covers the entire 300 kilohertz of the 40 meter band. But it's awfully touchy to try and do that with a single knob, with a single turn knob. What
about actually trying to implement a rotary encoder?
I've seen people talk about it. I don't know. Allard's code doesn't do it. I don't know if anybody else has published code that uses a rotary encoder for for tuning. That would certainly be my preference as well. Having said that, the cheap rotary encoders that you can buy on eBay or wherever, they're really not very good for large tuning. Like, excuse me, if you want to, tune 200 kilohertz down, you just want to go, you crank the knob around. Those kinds of rotary encoders don't do well with that kind of fast, long tuning as well. So the rotary encoders that you have on like a commercial radio is a much, much, much better and much more expensive rotary encoder. So it could be done, certainly. I don't know if anyone has, and I'm honestly not sure how well it would come out.
Well, there's probably there's a lot more to it than even just the encoder, because the encoder is just there's the mechanical stability and the accuracy of the mechanics, but then there's how you write the encoding algorithm. So the simplest encoders, you're just seeing an indication of which direction the encoder is rotating based on the kind of the phase shift of the signal. Mm-hmm. And then if you're just, every time you see it shift, you're just incrementing the counter. That's a simple way to do it. But you can also put like velocity in there. So as you see the rate of change, then the increments could be greater. In other words, you go faster not just because you spin the knob faster, but it sees the count go faster. And instead of jumping every 50 hertz or 100 hertz, it jumps every kilohertz. I mean, you can get as crazy as you want in the software for the encoder.
I was going to say, I've seen push button encoders that are a rotary encoder that also you can push in. And I mean, honestly, like a lot of modern HF radios, if you wanted to, and there are pins available, you could set it so that you push it in to change which significant digit you're tuning.
Oh, that would work. Yeah. I think
you can do honestly, you can do like a direct frequency entry thing. I mean, ultimately, it's just the user interface to tell the synthesis chip where to go. So, putting in a mechanical encoder, it really wouldn't be hard. The tricky thing, maybe one of the reasons people don't do it, is a really good optical encoder, which is a high resolution, smooth bearing kind of shaft encoder, is about $20 or $25 just for the encoder. And if you spent $55 on your radio, $25 on your encoder, let alone the knob. Oh, if you want a nice knob, you probably want a nice metal heavy knob. That's going to be more. So maybe people haven't done it just because it's sort of, I'm gonna, is gilding the lily.
Yeah. If you go to that level, but do you want to know where you can get push button rotary encoders all day long for like $2?
Micro Center,
pretty much, and not even rotary encoder. You buy a mouse, your scroll wheel. And actually, what's hilarious is I'm sitting here thinking about this. I know you're going to talk about cases in a moment, and George. To your point, actually, I had an optical rotary encoder installed in my Elecraft KX3. That was an option that they started offering well after my radio had left the factory. And I had it in, and yes, it's awesome, and adjustable drag and all this, and the big heavy knob. But if you think about the scroll wheel on your mouse, that's a clicky, I personally prefer clicky scroll wheels. I can't stand scroll wheels that are just continuously smooth. But yeah, you rip that mouse open. Imagine mounting it on the side of the case so that the rubber of the wheel, instead of being perpendicular from the desk you're operating from, it is that the I'm trying to figure out what the word is, that the main part of the wheel would be parallel. In other words, the axis of the wheel would be perpendicular to the surface of the desk. Yeah. And you have the push button capability there, and you can go back and forth. And that might be an interesting way to interface with the radio that's much different than what you do today.
There was actually a guy on the groups.io group that was suggesting this very thing. And because I remember now discussing with him and others about USB mice versus PS2 mice, because USB is very difficult to interface with on a microcontroller that doesn't have a built-in host controller. And the Arduino is a Arduino Nano, which does not have a host controller on it, so that he would have to get a PS2 mouse. But if he found a PS2 mouse, that'd be very easy to interface with, because you can have the encoder wheel plus the 3 buttons from the mouse that all come in on a single pin on the microcontroller.
So, stupid question is, what does that signal? I've never thought about this before. I mean, I know that the PS2 connection is technically a serial connection. What do the signals look like to differentiate between the different buttons and then the encoder directions?
Oh, I've not looked at the PS2 protocol, but it's a digital protocol. It's
it puts out a stream of hex values or numbers. You know, it's its own. It's kind of like getting ASCII characters out of it, but it's not that. It's a different set of bit patterns.
I mean, you can go look at the PS2 mouse protocol if you want.
Actually, I had a little project I did that was a CW sending keyboard, and I used a PIC microcontroller, and it used a PS2 keyboard, and there's a little routine to like read the bit pattern. So every time you press the button on the keyboard, it sends like a pattern of 7 bits or whatever it is, and you just have a lookup table to look at what that bit pattern is and say, oh, there's the character. So it's asynchronously sending bytes of data that correspond to which buttons are pressed.
Yep, and it's sending the scan codes, right? So the key down, key up, messages.
Yes.
Yeah. So you got to, on a keyboard, you have to map that to ASCII. It's not just sending ASCII data. The mouse is a little bit different. I don't remember exactly how the mouse works, but it's all documented. You can go look it up. And there are libraries that for the Arduino that automatically implement all this stuff too. But yeah, that was something that was discussed on the groups.io page.
Yeah, actually, I'm finding a thread now that I'll include a link on. Actually, what's kind of cool is you guys are talking, I'm kind of clicking through this groups.io, and there's a lot of, hey, has anybody ever tried?
Oh, yeah.
Like an optical encoder?
I cannot recommend enough, if you're really interested in getting into the BitX40 and just learning about it and listening to people who are way more experienced than you on this sort of thing, talk about it and learning from them.
If you're talking about me, that's like everybody.
Well, it's even me. It's everybody. There are so many people on this list that are just way smarter than me. And excuse me, I don't want to do that because that sounds self-deprecating. That are way more experienced at this stuff than me. And I have had great experiences by going on to the list and asking questions and admitting ignorance and saying, hey, this may be a stupid question you guys have handled a bunch of times before, but how, Asher, you're talking about matching diodes. What is it about a diode that needs to be matched? Are you just matching the forward voltage drop, or are there other characteristics of a diode that need to be matched as well? That was one of the questions I asked, and he came back with a very good, very complete answer, talking about the forward voltage drop graphs and related to current and the internal capacitance and the switching time and the various different things that in a diode matter when you're using them in a ring mixer. And so, I mean, I have learned a lot on that list. I also try to kind of help out and explain to other people when I get to it first. If I happen to read the email before somebody else beats me to it, I'll try and explain things as best I can as well. And kind of give a take there.
Oh, cool.
Really good group. Yeah.
Actually, and one thing I'll just point out as a complete aside. So groups.io is, I think, Google helms that, correct?
I don't think so.
No, I think it's independent.
Oh. Well,
we put all of our ham radio club stuff on groups.io. We moved off at Yahoo when it started to get shaky.
Well, and that's what I was going to say is that honestly, it's bizarre is probably the wrong word, but the fact that the fact that like the majority of the best ham radio kind of technical forums are all still on Yahoo groups. I've recently become aware of groups.io, mainly through, I mean, we had talked about it here before, but mainly the AirSpy developer has a group.io. So I'm starting to see more and more ham radio content show up over there, and it is a much better experience than what you had with Yahoo groups, in my personal opinion.
Which doesn't take much, to be frank.
Well, the old Yahoo thing did the job. I mean, it was fine, but a lot of our members were concerned that they didn't know what would happen to Yahoo eventually, and so we looked around and decided to try groups. The cool thing about groups is it's fine, but the best part about it was they have a service that lets you port all of your subscribers from your Yahoo group to your groups.io group, and so that worked seamlessly. It was great.
That's cool.
Cool. Sorry to digress. Back to hacks.
No, that's good.
Not that we've ever done that before.
No, never. So there is. Well, no, I lied. I was going to say there's one other modification I want to talk about, but there are a few. So one of the things that I wanted to do, since I learned about the BitX and started learning how it functioned, that other people have done, and I'm not trying to claim that I'm the first to do this, but Allard Software doesn't do this, and so I've had to actually maintain my own modifications to his software. In the BitX, go back to, if this doesn't make sense to you, go back to the video that I did on YouTube describing how the BitX works at the block diagram level, and I'll be able to explain the difference then between a VFO and a BFO, or the local oscillator. So on the Arduino, there is one fixed oscillator called the BFO, and it's at a given frequency. It's a crystal-controlled oscillator. It doesn't move. It's a very stable oscillator, and it stays in one place. One place meaning one frequency. Excuse me. It stays at one frequency all the time. It does not change. And then the second one is the VFO, the variable frequency oscillator, and that's what actually does the tuning on the radio. In the very first BitXs that came out, the VFO was entirely analog, and I love my analog VFO. I got a second BitX that's all unmodified, and it's got the analog VFO, and I love it, and it's drifty as all heck. It is a horrible radio by conventional standards, but I love that radio. You have to stay on top of the tuning knob to keep it in where excuse me, keep it where you want to be transmitting and receiving. So the Raduino replaces the drifty VFO, but it does not replace the BFO. And that's fine. Most times the BFO doesn't need to change. The frequency of the BFO needs to match the frequency of your crystal IF filter. And I use the term match loosely. I don't mean that they're exactly the same. They need to be offset by about 1.5 kilohertz, because you're trying to pass audio between like 300 hertz and 3000 hertz, right? And so the center of that is at 1.5 kilohertz, and the carrier frequency for the BFO needs to be at the quote-unquote 0 hertz point in the signal that you're receiving. Anyway, go back and watch my video, and I explain this stuff a little bit better. But because the BFO and the IF crystal filter frequencies are tied together in this way, the BFO doesn't really change, unless you specifically are trying to change the properties of the IF. And one of the features that my Yaesu FT920 has that I love and I use a lot when we're in a contest situation is called an IF shift. And what that does is normally your IF is centered around somewhere near like excuse me, like 1.5 kilohertz or 2 kilohertz, or I'd have to go do the math to figure out exactly where it is. But basically, it's about a 2 to 2.5 kilohertz wide filter that is centered right around your audio, from 300 to 3000 is pretty typical, or 500 to 3000, or wherever, somewhere around there, right? But sometimes you might want to shift your IF up by 100 hertz or 200 hertz or 300 hertz, or you might want to shift it down by 100 hertz or 200 hertz or 300 hertz in various conditions. By shifting your IF up in frequency, then you will be listening to and sending out much more of the excuse me, the high frequency components of your voice, which will actually, I have an EQ on my mixer here where my microphone is coming in. I just turned down the lows on my microphone audio, and so hopefully now my voice sounds a lot tinnier than it did before.
Oh, yeah.
Okay, good. Because this is a demonstration of what I'm doing. So what I've just done is I've shifted my IF up in frequency. You are hearing the consonant information of the audio that I'm sending out, all the high frequency information, but without the low frequency information. And you can still understand what I'm saying. It doesn't sound high fidelity, but these kinds of high frequency sounds are what you need to break through a pileup. They tend to be better for DX or contesting type situations.
So let me make sure I understand something real quick. So with this IF shift, on a modern radio with fancy DSP, we're used to IF shift. It does the same thing for the receive signal. Is this just IF shifting your transmitted signal, or does this also allow you kind of shift around the pass band for the receive signal?
So in fancy radios, it is typically only on the receive channel. I do not believe that the IF shift, at least not on my radio, my FT920, I believe the FT920 only shifts the IF on receive. And I'll be honest with you, I don't know that for sure because I've never actually listened to my own transmit audio on that while playing with the IF shift.
I mean, normally the IF passband adjustments are strictly in the receiver chain. It's strictly the receiver's IF because the transmitter, its multiplication chain is probably different than the receiver, and so you're really only adjusting the receiver IF.
Yeah, I don't think my question was clear at all because I was talking more about the BitX40. Okay.
So on the BitX, what I'm talking about by the way you change where the IF lands on your audio, on the signal that you're transmitting, is by changing the frequency of the BFO. And so the modification that I made is that the Arduino is capable of outputting 3 different RF signals, but by stock, it's only using one of them. And so there are these 2 additional DDS outputs that can be used if you want to do something with them. Well, I grabbed one of them and I replaced the BFO on the Arduino with this second output from, I replaced the BFO on the BitX with this second output from the DDS, from the Arduino. And so this allows me to actually shift that IF around. Right now in software, I am not having it change the BFO whether I'm transmitting or receiving. So the way I've written the software so far, it is shifting the IF on both transmit and receive audio. However, that's just a software thing. Because I have complete control over the BFO, I can shift it for receive and not on transmit, or I can shift it on transmit and not on receive, or shift it on both or neither or whatever. It's just a matter of implementing the software to do that. And I haven't done anything more than just a simple all the time shift yet.
So, of course, I don't expect that this radio is contest quality by any stretch of the imagination, but if you did have an incident where you're trying to talk to somebody or hear somebody where there's another, like, say, close-in sideband signal, you can use the IF shift to basically try to tune it out.
That is exactly why how I use the IF shift on my big radio, yes.
That's pretty amazing for a $60 radio shipped from India with a little time and ingenuity. And again, I'm seeing another use for yet another disemboweled mouse scroll wheel.
So the BFO from the Arduino is not a modification that the standard software, Allard's software, supports yet, but he is planning a version 2.0 of the software that's going to not be backward compatible with Asher Farhan's original software. And so that's going to be the big break. Right now, everything he's done so far has been backwards compatible, but he's going to start on a 2.0 version that will not be backwards compatible, where he's going to make a bunch of enhancements and improvements that would break backward compatibility. And one of the things he's going to do is that he's going to add support for BFO from the Arduino, and we'll be able to do all kinds of things. I believe this also allows you to do a much simpler method for getting upper sideband. I'd have to go back and do all of the multiplication math, but I think you can end up shifting the BFO from the lower side of the IF filter to the upper side of the IF filter and end up getting the same thing. What are some of the other ones? Oh, I'm also working on a front panel in case. So I'm not as elite with the 3D printing as Jeremy is, but he's been kind of helping me out with trying to get some 3D printed front panels for this plastic case that I bought from Banggood set up, and it's got all of the right shaped and sized holes for all of the knobs and everything that I want that my radio has, with labels in the cases, the front panel itself. So you can go see pictures of that on Twitter. Once I have a front panel that I really like, that ends up working out, then I will probably post that file somewhere for people to use, but I'm not ready to do that yet. Okay. So one last modification that I want to talk about. I have not done this yet. I have heard of other people doing it, but I have not done it myself yet. And that is that the BitX40 is a very modular radio design. There are only 2 sections on the radio that are specific to 40 meters. And those 2 sections are very easy to replace. There is a band pass filter and there is a low pass filter. And both of those are very easy to get to. They're on the outside edge of the board. You can cut 2 simple traces to be able to replace them with other things. And so if you replace the low pass and the band pass filter with, say, a 20 meter low pass and band pass, and then you change the frequency of the VFO, then you can turn it very easily into a 20 meter radio. Similarly, if you replace them with an 80 meter low pass and band pass and change the frequency of the VFO, then it has become an 80 meter radio. And so I had this crazy idea of buying those QRP Labs low pass filters and band pass filter kits that we were talking about earlier, and 2 of the relay switching board modules. Excuse me, 2 of the relay switching modules. And I'm going to use one of the relay switching modules to switch out the low pass filters on the power amp of the BitX, and the other one to switch out the band pass filters in the signal path on the BitX, and then control which of the filters is in place from the microcontroller. And in this way, I hope to be able to make a multi-band BitX. I believe the modules I bought were 80 meter, 40 meter, 20 meter, and 10 meter. So I would love to be able to just kind of cover all of the big main bands in a single BitX.
No 15?
That seems pretty exciting to me.
No 15.
No love for the 15. I don't know. I only had so much space.
Hmm.
Why are you a 15 lover?
I've made far more contacts on 15 than I have 10, I guess, in my career. George, what say you? Call sign A.
Well, I'm rather fond of 200 meters myself.
200 meters.
Okay. You youngsters with your high frequency radios and all, really for me, 20 and 40 is kind of where the action's at. Frankly, as the sunspot cycle goes sliding down the trough, 40 is going to be better. I don't think we'll see a whole lot on 10, spotty on 15. And, I'd focus on 20 and 40 mostly.
20 meters has the advantage of being small enough wavelength that it's actually reasonable to be able to put up directional antennas at my house.
Mm-hmm.
I am looking at a Moxon design. I'm also looking at the hex beam, but I don't know how much money I want to spend on a hex beam that does 20 meters that I want and a whole bunch of other bands that aren't going to be good for the next several years.
So here's I've got a suggestion for you to look at.
Okay.
So this is another off-topic topic, but take a look at Step IR. They introduced a new thing called the Urban Beam. Have you seen that?
I have not seen the Urban Beam, but the last time I checked Stepper, they are gorgeous, wonderful, delicious antennas that are so expensive.
They are that. But just for idle curiosity, take a look. So what this thing is, basically, it's like a Moxon antenna with their extending, telescoping, tape measure elements. So imagine there's a rectangle and it's 2 elements. And when it's, let's say 6 meters through 20 meters, you have a driven element and a reflector. So you have a 2-element Yagi. And on 40 meters, I guess the director sucks in to nothing, and the driven element is extended and loops around like a folded dipole. So it's not a 2-element Yagi on 40. It's essentially a folded dipole on 40, but that's a whole lot better than nothing on 40. So I think they're like $1,500 to $2,000. I mean, they're like it's an expensive antenna, but it is 6 meters through 40 in a horizontal plane. So it's very appealing from a noise point of view, and it's not super big. I think the turning radius is like 12, 13 feet or something like that.
15.5.
15. Well, you guys know more than I do. So 15 feet turning radius, not too bad.
Wow.
So there's something to think about.
Yeah, to be able to put a rotatable dipole on 30 and 40 meters would be pretty epic.
Would be with no traps.
With just 16.5 front to back. Wow. Yeah. But
it beat the heck out of my my vertical. I mean, my vertical is okay. The problem with it is it's noisy. And sitting here, in town, you get a lot of electronic noise interference, and I probably get 4 or 5 dB more noise than if I had a horizontal antenna. So that'd be, I don't know, serious thought.
Well, I've got so I used to have an R8 up on the roof until I took it down to do some maintenance, and it fell over and got in a fight with the fence and lost. Yeah, you go look at my Twitter profile, and there's a picture of.
I've seen that. Yeah, that was
R8 all bent up.
Oh, that was a disaster.
So I used to have that, and it was great it would pull in lots of low angle signals, but it was also noisy as all heck. So I have right now an 80 meter, 40 meter, 30 meter fan dipole, not a trap, but a fan, up with the center at about 30 feet right now, 32-ish feet. And then it slopes down, so it's an inverted V down to about 10 or 15 feet on one side, and I think about 20 feet on the other side. And that is doing okay, but it's not pointed in an ideal situation or in an ideal direction, unfortunately. Excuse me. So I would love to be able to put something up at like 30 or 40 feet on a pole in my backyard, and then be able to rotate it. That's really the killer on that, is the rotation.
Yeah, you get a little bit of directionality. Mainly you get, Jeremy, I think you just said front to back, but you also get some side rejection, even if it's only 2 elements. So I think that'd be a nice step up. I mean, for those guys listening who are thinking, wow, that's a ridiculous antenna. I've got 6 elements on 20 wide spaced. And like, well, okay, yes, that would be better. But for those of us who live in a suburban lot with a big antenna, is not going to happen. So this might be about the biggest Yagi I could get away with.
Yeah, that 15-foot turning radius is pretty epic, especially for one that covers 40 meters. That is insane.
So basically, to clarify, when they say the boom is 4 feet long, so that's the I guess I hate to say front to back, but it's the front to back. Yeah. And then each side off of that, it's 15.5 feet.
Right.
I mean,
so it's a big rectangle. It's a big, 15 by 4 foot rectangle. Yeah. Right. Well, it's kind of pinched in the center.
30 by
correct.
Yeah, 30. Yes. But still, I mean, it's not trapped. I mean, that's granted. It does 30 and 40 meters, which the classic, to me, the de facto Yagi that I have any experience with, of course, is like the classic Mosley tri-band, and that's a fairly large antenna.
Mm-hmm.
I don't know if it's 30 feet large. I don't remember, but this looks really cool. For me personally, if I could put it up, I don't think it's $1,700 cool.
What caught my eye about this antenna really was the fact that it had 40. So,
dang, that is compelling.
Yeah, it is a bit pricey. They're not cheap. They make nice stuff, but they're expensive.
But we digress.
But we
digress. Well, only sort of, because this would be an antenna that I could use on all of the bands. Although I guess not 80, but on most of the bands that my BitX would support when I go multi-band BitX on this thing.
And I think it's great if you have a $2,000 antenna plugged into your $65 radio. I think there's just something special about that.
That's about where the money should be spent. Let's be honest.
I'm not saying that totally tongue in cheek. I mean, I'm almost kind of serious because a lot of guys will tell you put all your money in the antenna, and sadly for most of us, that's the hard part.
Yeah.
So.
Yeah. I very intentionally picked this house to not have any restrictions like that for antennas. Now I still have to appeal to the wife, but not to the neighbors.
Wait, because you don't have any?
No, I definitely have neighbors. I don't have that much property. I wish. If I did, I probably wouldn't have to worry too much about whether my wife would object.
So, is there anything on the BitX, other mods or things that you would be looking to make that people are talking about? Like, what's the kind of craziest thing you've heard about?
Craziest thing? I don't know.
I mean, like putting CW decoding in there, that was kind of an interesting idea.
Yeah, that's one. A lot of people don't like the 16:2 character display. So there are kind of mods out there. People have done the 20:4 character displays. So that's a pretty easy mod to make because it uses all the same libraries, and all you have to do is add some output. There's a one function where the screen gets updated, and all you have to do is go in there and change some of that code, and it's pretty easy to do. There have been people who have been talking about using, using what are they called? Bitmaps. Great gravy, graphical displays. But none of the common software packages support that. So I don't know how far that's getting down the path.
Well, so I'll comment on that. I've put a link into the show notes. So oddly enough, the gentleman ham who lives here in my community, Dr. Jack Purdom, Whiskey 8 Tango Echo Echo. You actually pinged me the other day, Mark, and said, "Do you know this guy?" And yes, I have met Dr. Jack from my initial contact with the radio club here in my town. And actually, at that radio club's Hamfest at the start of the summer, he and I had a chance to catch up, and I got to see a couple of his BitXs that he had there, and he had a beautiful full color TFT. That had on the display, there was a obviously your tune frequency. I believe it was a touchscreen display because there were like some soft buttons for selecting like CW messages, and there was an S meter even.
Oh yes, that is one thing that a lot of people have been talking about doing. Oh, and there's another one, AGC as well, automatic gain control. Those two kind of go together to some degree.
Yeah, and I don't know all about this. I put a link to where he's talking about ordering it. There's a nice manual and parts list and modifications. I don't know about the actual software, but I know he actually went out and had boards fabricated, and occasionally will do runs where people can order them. And yes, I actually do remember that he had the AGC mod in his radio when I saw him at the Hamfest as well. Actually, I might run into him tomorrow. I forgot to mention, I am going to what is effectively the last Hamfest of the season here in the Cincinnati area tomorrow from the it's the Okayan, which is the Ohio, Kentucky, Indiana Repeater Council. Maybe I can't remember what the whole club name is, but looking forward to doing that in 6 hours from now.
So, are you just pulling an all-nighter?
No, Lord, no. Like I said, I won't be editing this tonight. I will be heading to bed. I told our club president, KD8FYT, in the Ohio Valley Experimenters Club that, I will not be there setting up with the club for our booth at 06:30. I will try to be there by 8.
Oh, wow.
Now, as far as that AGC mod goes, is that another board that people are producing, or is that, just throw some additional components on?
So there are many different ways. There's actually been a lot of discussion lately on where is the best place in the circuit to add the AGC. I'll be honest with you, I didn't follow all of it, But it's not just as simple as, hey, well, I've got loud audio coming out of the speaker. Let's turn that down some. There are better places in the signal path to be able to actually apply your attenuation. So I don't think I've seen anyone. It's not like an external board that you can just easily patch in, the speaker out from the BitX into this board, and then the out from the board into the speaker port itself. It's not that simple. So I haven't actually looked into the details of it, but it is nice. So the BitX does not have any AGC in it, which, if you haven't ever done it, take your commercial radio and turn your RF gain down to the point where the AGC is not being engaged for background noise. So you want to turn the RF gain down, and you'll hear the radio get a lot softer, and then the AGC will start, stop backing off, and the volume will start coming back up again. And then you turn it down a little bit more, and it will go down really quickly, a little bit more, and then it will come back up again to kind of the constant volume. And you turn it down until it stops doing that. And now you've got it to the point where the AGC will only engage when there is a strong signal coming in. And it is a new experience, man. I had never done this before. I was always previously of the crank up your RF gain, turn on your AGC to fast mode school of thought when tuning around the bands. And the BitX, the analog version of the BitX, was the first one I'd ever owned that did not have an AGC and did not have an RF gain knob in it. And it was the closest I've ever come to being able to sense RF energy directly in my brain. It felt like a sixth sense that I was listening to the ether itself, not that I was listening to this signal that was heavily processed coming out of a speaker, but that like my brain was sensing radio signals directly. And so honestly, I'm not sure how much I want AGC on my BitX, because I really like this kind of direct observation of the radio. Quiet signals are quiet and loud signals are loud. It's not that quiet signals are noisy and loud signals are less noisy, which is what happens when you have your RF gain turned up and your AGC turned on. It's a whole new experience to me. And I'm sure other people have been doing it this way, quote unquote, correctly for decades, but I only just found out about this, by getting a BitX. So the AGC is there, and I think most people on the groups.io group kind of agree that you don't want the AGC to engage very often, except for super strong signals. Because that is one thing. If you don't have an AGC on and you've got it turned up, so you're pulling in some DX stations, and then you're tuning around, and all of a sudden you're hearing your buddy down the street who's got his kilowatt transmitter turned on, you will blow your eardrums out if you've got headphones on and that. And so having an AGC to just kind of keep that kind of thing under control would be good. But I really, really, really do not want it to engage while I'm listening to just normal signals. So
as you were talking, I actually did find somebody has designed an audio AGC board for the radio and has uploaded them to OshPark and made them available for people to order. And it looks like you get 3 of them for about $12. So nice. I put a link in the show notes to that.
And then he or she, Duane's. So I'm guessing that's a he.
That's a he.
Yeah, and he just did that about a month and a half ago.
Seems nice. Recent. Yep. So I mean, the long and short of it is it's like your own personal radio adventure kit.
Yeah, I've had so much fun with this thing.
Well, I can't wait to start on this journey. I mean, just listening to you talk, there have been several mods that immediately come to mind. And honestly, while we're talking, I was kind of searching through the forums, and there were conversations about the mouse thing. And there definitely are people who've done it. And maybe that can be my contribution, because, these little wheels are pretty ubiquitous.
I think you need to design a new circuit board.
I'll make the mouse interface board.
Yeah, you should do it.
Well,
Wicked mouse interface.
what we'll do is, like maybe even a little PS2 interface so that you don't actually have to. But of course, you made the comment that the Arduino is quickly running out of space. Maybe we can create a network of Arduinos that power this thing.
God.
I know, it's Raduino at home.
Raduino at home.
You could do a big compute cluster to power your $65 QRP radio with about $400 worth of Raspberry Pis.
Yeah.
And don't forget to send it up to your $1,800 antenna.
Yeah. What's funny, right, is if you're a gearhead and you're a technologist and you get your radio license, everybody starts focusing on the shiny radios, and everybody in the forums are always like, I spent $3,000 on my radio, and I pulled some wire out of a lamp cord to use for an antenna. So this Urban Beam is your opportunity to put your money where your antenna is.
Yeah.
Oh, again, I just can't afford it. I look at it and I'm like, wow, that's super cool. And even if I could afford it, I couldn't put it up here. Maybe in the attic. Actually, that's the sad thing. It almost would make itself a very good attic antenna too, with only 15 feet turning radius.
Well, you have a pretty big attic.
Yeah. I can't imagine an attic where you have a 30-foot diameter circle that you could rotate this without any, structural members in the way.
Well, I guess that's a good point. Although, actually, I don't know if you caught it, but Dr. Frank from our last episode, K4 FHM, he commented that he has 17-foot headings in his attic alone. So he actually had his attic designed for antennas. So maybe he should look into this and report back.
Get right on that.
So, man, we've covered a lot. Like I'm jazzed. Like, George, what do you think sounds the most interesting for your BitX?
All of the radio mods and adding features and stuff sounds useful, but I'm kind of interested in figuring out how to package it up, because I think it would be fun is to figure out how to put it in a box with a battery and whatever other stuff, so it's kind of like a ready to go all in one thing. So we didn't talk about your chassis box, did we, Smitty?
I very briefly mentioned it. I got a $10 white plastic box that a lot of people seem to be using from Banggood. That's kind of the 2U, not as in 3.5 inches tall, but 2 U-shaped plastic pieces that connect together top and bottom, and then they've got separate front panel and back panel that are just flat pieces. And I've been designing in OpenSCAD a 3D printed front panel, and I'll get to the back panel afterwards, but a 3D printed front panel that has just the right shaped and size holes for all the things that I want to have on the front panel, because I've got 3 knobs, a volume knob, a tuning knob, and an IF shift knob. I've got the 2x16 character display. I've got 4 1/8-inch, the 3.5 millimeter tip ring sleeve connectors for headphones, microphone, PTT, and keyer, and then 4 buttons on the front. And so rather than drill holes in a piece of plastic and not have anything marked, and hope that I got everything placed in the right spots, I decided instead to kind of design it and print out multiple versions of it. And that's something that I plan to share. That file is something I plan to share when I get done with it. The other thing I've done is I've replaced the potentiometers that came with the BitX. I'm not sure why. I don't know if he just got like a big bag of them at surplus for cheap, but the knobs or the potentiometers that he has for the tuning knobs are the shaft of the potentiometer is like 2 inches long. If you put a knob on the end of this thing, it would be sticking out of the front panel of your radio by a considerable amount. Similarly, the shaft for the audio taper potentiometer is like 2 or 3 millimeters wide. It's about half the diameter of a typical volume knob. So the potentiometers that he ships with the radio, I kind of, I added them back to the junk box, and I pulled out some good audio quality potentiometers that from Panasonic that I've used in a lot of my audio projects in the past. I had some extras of those laying around. I have a lot of audio tapers, but I don't have a lot of linear tapers. So I actually need to go buy some more linear taper potentiometers for the tuning and for the IF shift. But these are all PC board mount potentiometers, and I just have wires soldered to the pins right now. But I'm actually thinking once I settle on a front panel layout, I'm going to make a circuit board on the back that you solder these 3 potentiometers into, and then you solder the 4 buttons into, and then it will just have like a single connector that goes from that into the Arduino, rather than having all of these cables go cattywampus, because a lot of the potentiometers and buttons all share a ground, and so I've got a ground wire going to each one of these things. Rather than doing that, just have a single ground go to the board, and then the board would distribute the ground to everything. Same with power for the tuning pot and the IF shift pot are just voltage dividers. So you just need power and ground to go to either side of the pot on that. And there's no need to run multiple wires for that. So I think I'm going to do that circuit board. The way the front panel is laid out, the audio connections would be a different circuit board, but I also have PCB mount, 3.5 millimeter TRS connectors, and so I might make another board for all of those connectors, and then just have 1 or 2 or 3 or however many connectors it is that it's convenient to run over to the board for all of those connectors as well.
How does the audio sound on the receive side? Is the level high enough, or would you put an audio amp on it?
Oh, good grief. It's got an LM386 on it, and I've actually had to remove the capacitor on pins 1 and 8 on the LM386 that increased the gain. So because I use headphones, not a external speaker, I actually turned down the gain on the audio side. So
there's enough audio for earbuds, but if you're driving a speaker, do you think you need some amplification?
Honestly, I never use speakers in my applications, so I don't know. But I've never heard anyone complain about it or say they wanted to hook up an external amp. But definitely with headphones, I popped off that one little capacitor on pins 1 and 8 and dropped the gain down to a reasonable level for headphones. But I don't know about driving a speaker with it. Everyone else is doing it that way. I don't know about everyone, but lots of other people are doing it that way. So I assume it's fine.
Sounds great. Well, anything else you can think of that you'd do to it?
One of the things you can do is that the PA, the final outputting amplifier, it has its own voltage source, and if you run the rest of the radio off of 12 volts, well, you have to run the rest of the radio off of 12 volts, but the PA can be run at a higher voltage and get more power out of it. So the wiring I have on my board right now has 2 different power supply inputs. I actually use Anderson power poles because we power pole the world, right, Jeremy?
That's right.
And so I've got a block of 2 Anderson power poles and a little panel mount connector adapter thingy. And the power switch that I rigged up for this thing switches both of them separately. So you can supply 12 volts to one of the Andersons to run the majority of the radio. And then I think you can drive the PA at up to like 24 volts or 28 volts or something, a much higher voltage, and get a lot more power out of it. So that's another thing. I don't know that I'm ever going to do that, but it's there, and I've got it rigged up so that I can do it. But other than that, no. I think once I get all of these mods done, I'll have a neat little QRP radio. It'll do multiple different bands. It'll do voice. It'll do CW. It's got the IF shift on it. Yeah, I mean, I think I'll be pretty happy with that.
I mean, it really is a remarkable amount of radio. I mean, George, we joke about how long you've been a ham, but I mean, if you think about what you can build for, $60 to get started, and, a few hours of coding and maybe anywhere from $10 to $40 in extra parts. I mean, compared to a radio that you would have bought in the 70s.
Oh, gosh. Well, the funny thing is the first QRP radio I ever played with was a Heathkit HW7. And on a scale of 1 to 10, that was probably about a -4. So it was, and I'm sure I've insulted somebody who dearly loves their HW7, but it's a direct conversion receiver. It was microphonic. You tap the case and, you could hear it.
Oh, yeah.
It was just awful. I mean, in every conceivable way, it was a crappy radio. And I don't know what they cost at the time. It was probably $150 or something like that, which of course now would be like $300. But man, like and that was CW only. This BitX is probably a way better radio than the HW7 was for a fraction of the cost. So, it's really cool to see this. Just like we talk a lot about the microcontrollers and the Raspberry Pis and all that. So what you can get for next to nothing in that world, we're starting to see a lot of that stuff in the radio world as well. And I think the stuff that Ashar is doing is just phenomenal. Propel this along, and I love seeing the community. I mean, I think I get the biggest kick I get out of this, frankly, is all the guys who come after and say, "Oh, I need to do an AGC circuit," or "Oh, I need to do a new VFO," and then go off and because that bugs them and they want to do one, and all the other stuff is already done. That framework is there. They just need to improve that one piece. And when a lot of guys do that, then everybody benefits from that. And I just love seeing that.
You asked me if there was one other thing that I would want to do on this radio, and it's something that I want to wrap up tonight, but I would love to come back and talk on another episode after I've actually had a chance to do some of this. But one of the things that working on this radio has shown me is that I have a severe lack of test equipment. And I'm not talking about voltage, like a voltmeter or anything like that, but I'm talking about I don't even have a watt meter that will measure 5 watts. I'm not even sure I have an external watt meter at all. I think the only watt meter I'm using has been actually built into my FT920. I don't have a watt meter. I don't have an SWR meter that will read at the low powers that this thing is doing. I have no way of sampling my signal without just hooking up an antenna and transmitting it low power and then turning on my other rig and disconnecting the antenna and just hoping it bleeds through, right? What I really want to build is a box that has a watt meter in it, that has an SWR meter, measurements in it, that will allow me to do a sample out of the signal that I can send over to an oscilloscope, that has a frequency counter in it, that has maybe a dummy load, right? All these things, but scaled down for QRP, which is hard because a lot of the commercial things that you find, they're scaled up at about 100 watts, where it's very easy to measure these things because you got high enough voltages that your diodes don't do a lot of forward voltage drop. But when you're doing it down at 5 watts, your voltages are low enough. The voltage drop across your diodes for when you're sensing these things is a significant portion of your total power. So it's a little bit harder to do. And I've seen some schematics online that can do QRP SWR meters and a QRP watt meter and all of that fun stuff. And I want to put together a QRP test kit, if you will. And I think the parts I want in it are a frequency counter, a watt meter, an SWR meter, a dummy load, and a sample output. And I think that would be a very useful kit for not just the BitX, but in general. And and I haven't seen one thing that has all of those things in it, and I would love to make that.
So I think that's a great idea. This is along the lines of what Barrick and I were talking about in thinking over what sort of things would you want to build out your workbench in terms of test equipment, low cost homebrew test equipment, like signal generators, like using an SDR as a spectrum analyzer, like all the things you just said. So you might want to even bounce some ideas off of him because he's thinking along the same lines. I think that would be great. By the way, we did a simple example with a Smarty load where it was not a calibrated watt meter, but the core electronics to just measure an RF voltage and then convert that to something useful in wattage is for coarse measurement is very simple. Making it more accurate is kind of the trick. The tricky part really is making it flat across the spectrum. But for a given band, you can make it work pretty well.
So there is the North Georgia QRP kit. The North Georgia QRP Club, I guess. They made a kit called the Noga Watt, NOGA, as in North Georgia Watt, which is a QRP watt meter, forward and reverse watt meter, and I have one, and I could never get it working properly. But I'll include a link to this in the show notes. But I think this is going to be, once I get the BitX put together, this is going to be the next thing I do, because I don't really know how much power I'm putting out, or how good of a job I'm doing at rejecting my carrier, or, those kinds of things. And I really want to be able to get a better view of that.
Well, Smitty, thank you so much for stopping by again, and thank you again for the gift of the BitX40. Thank you for your mentorship in laying out a board and talking me off a ledge a time or two. Thank you for sharing all these amazing BitX40 changes. I'm going to ask if you have an opportunity to try to put as many links into some of these things, because I noticed there's a lot of different ways to skin these cats, and if there are particular instructions you think are particularly helpful, that would be wonderful to throw in the show notes.
Well, you are absolutely welcome, Jeremy. I really appreciate the opportunity to come on and chat with you guys about it. I always appreciate you inviting me on to heckle you while you're doing stuff. That was a good fun. So thank you for including me in this wonderful little workbench thing you guys have created here.
Hey, thanks for being willing to participate. All right, we're going to take our final break, and we'll close out when we get back.
This episode of The Workbench is brought to you by Autodesk Eagle PCB Design Tools. All of our projects we're doing on the Workbench use Eagle. It's great for schematic capture and board layout. You can easily generate all of the output files necessary to manufacture a circuit board. And whether you're building one board or 100 boards for your friends, use Eagle tools because they have really excellent support. They've got a great library of available components. It's widely used amongst the maker and the professional board design tool. You'll enjoy using the tools, and there's a lot of great new features. Check it out at autodesk.com/eagle, and you could download a free copy of the PCB design tool today and get started doing your project.
So that's it for this week. Don't forget to check us out online at www.hamradio360.com. If you want to participate in our Facebook group, please find the Ham Radio 360 group on facebook.com. If you would like to send a note to George and myself to give us feedback about the show, ideas for upcoming topics, if you have something you would like to come on and talk about and share with our listeners, please send us an email to Workbench, all one word, at hamradio360.com. In the meantime, in the social world, I am on Twitter at KF7IJZ.
And I'm at KJ6VU.
And Smitty, how would folks find you online?
On Twitter, I am at Smitty Halibut, SMITTYHALIBUT. That is probably the best way to get a hold of me. You can also find my very long form, very non-scripted, non-edited YouTube channel videos. Search for Smitty Halibut on YouTube. And if you enjoyed watching Jeremy lay out the circuit board or that kind of video, that's a lot of what I do. I just kind of sit down and start up the stream and start working on a project.
That long, unscripted, unfiltered, unedited, unorganized, that's part of the reason why you were such a natural guest on our show.
You getting me to shut up is usually the hard part.
All right, folks. Again, please keep sending those messages and those questions. Feel free to reach out. We do try to respond as often as possible. Actually, George, here at the end, I think it's safe to announce one other thing that we know for sure in case anybody was wondering, and that's that we have decided that we will not be resuming board manufacture for the rest of 2017 because there are a ton of new projects in the hopper, and we're going to look at what we're going to have to offer, and I'm really holding out hope we can get an Antenna Analyzer 2.0.
Well, we'll take that up with the engineering department.
That's right. Thanks, as always, for listening. 73.
This weekend on September 22nd is the annual D-Star QSO party. Bet you didn't know there was a D-Star contest. This weekend, several stations from all around the world are making contact, and we thought we'd record some of that traffic and play it for you here in the podcast. Enjoy.
Kilo Delta 4 NEI, this is VK3TQ. Good afternoon to you. The name's Peter, and the location is just north of Melbourne in southeastern Australia. My number to you is 592006. 592006. QSL.
Line business, Peter. I copy 592006. You are 592017. Thank you for my first D-Star contact.
Oh, really? Well, that certainly is a 2017, isn't it? And welcome to D-Star, and hope you have a lot of joy out of it. You've got a nice signal down here in Melbourne. Really, really good. KU4 NEI, VK3TQ.
That's Peter. Thanks to Goody Threes.
Stage 73s.
CQ, Victor Kilo to Alpha Hotel, calling CQ for the D-Star QSO party. Golf 1 X-ray Victor, VK 2 Alpha Hotel.
2AH, this is 01 ICU.
Zulu Lima 1, India Charlie United. Zulu Lima 1 ICU, which I can't from here, Laurie. Haven't got good enough eyesight. 5-9-2008.
Roger, mine to you is 5-9-200.
Lima Whiskey 2, Echo Queen Uniform. Thank you for the 2011. My number to you, 592008. 73s, good luck. Yeah, VK3 Tango Quebec, I think it is, VK 2 Alpha Hotel.
Roger, Brian, good morning. And it's Peter here, and how are you going? And my number to you is 592006. 592006. QSL.
592006. Thanks, Peter. Good luck. Bye-bye.
Yankee Bravo Zero Alpha Zulu, D-Star QSO party, QRZ.
What was your number, Brian? What was your number, over?
008. 2008, QSL. Yankee Bravo Station, Victor Kilo 2, Alpha Hotel.
Kilo 2 Alpha Hotel, good morning from Jakarta, you're 592013.
Okay, I'll just confirm. Yankee Bravo 0, Alpha Zulu. Confirm your 2013. My number to you is 5-9-2008. QSL.
Roger, QSL 73.
YB0AZ, this is 01 ICU.
Jadwell 1 ICU, good morning, Q592013.
Of course, I is 01 India Charlie Uniform, and my number to you is 5-9-2007, over.
Thank you, orders 200773.
YB0 Alpha Zulu. YB0 Alpha Zulu, VK3 Tango Quebec. Victor Kilo 3 Tango Quebec.
Victor Kilo 3 Tango Quebec, you are 592013.
Thank you very much. The name's Peter, Peter, my location's just north of Melbourne, and my number to you is 592006. 592006. What was the name there, over?
Good, all VK3RQ from YB0AZ. Your report is 592013, and name here is Whiskey India Sierra. This is Jakarta, Q-Zone.
Thank you very much, Wiz. Thank you very much, and nice to work you, and good luck in the DSTAR QSO party, VK3TQ.
The second segment you're going to hear is the 10 gigahertz and up contest. This happens twice a year in August and September. Let me give you a little bit of background about the contest. It's primarily focused around the 10 gigahertz band, but some stations also operate higher microwave frequencies, typically 24 or 47 gigahertz in addition to 10, but most of the action is on 10 gigahertz. So a couple of terms you might hear in the following recording. First thing you might hear is a reference to a term of liaison. Liaison refers to the intercom system that's used by the operators to coordinate their microwave shots. Typically that's a simplex channel or a repeater network. In this case, we're using the Cactus Intertie, which is an enormous linked repeater network that covers most of the southwestern United States. That particular repeater network has a lot of active hams, particularly in the microwave space. So when you hear about liaison, they're talking about intercom on the Cactus Intertie. You'll also hear the term rover. A rover is a station that's mobile and operating typically in a fixed point, but after it's done operating, it'll pack up and move to another location. So points are made by making contacts to different stations at different locations, and if you're in a different grid square, you can make another contact. You might also hear reference to the frequency of operation. You might hear a station saying something like, go to 150 or I'm on 300. Typically what this is referring to is the very low end of the 10 gigahertz band. So those numbers are actually fractions of a gigahertz, referring to just up from the bottom edge of the band. So most of the activity is at the weak signal end of the bottom of the 10 gig spectrum. We hope you enjoyed the traffic on the Cactus Intertie listening to the stations working the microwave contest.
Right now is coming from me to basic CDR. Signal Peak, Orange County. I'll explain. Robin, do you want to listen for us? I'm swapping with KDP right now, right? Okay, I didn't know that. N9KIM. Just my heading to where I think should be the right heading for you, and you can see if I'm better there. All right. Are you hearing me at all? No, I'm not. All right. I'll listen for you one more time, but if you're not hearing me, it's kind of a waste of time. So let me drop and listen for you, and then we'll carry on with the rest of the guys. I agree. So just one more time here and move on. I'm hearing you, but it sounds like you're kind of going in and out of lock. I don't think this one is, but it could be. I'm seeing a steady carrier on the screen. Well, I heard Robin before. It was very bursty. Propagation was causing the burst, though. Yeah, propagation's doing weird things. That's definitely true. All right, I'm looking for a signal, and I see nothing so far. Yeah, there it is. Little bursts. There's a burst of signal and then went away. On to other things. What I thought was right heading for you, if you didn't see it, when I put back on the old heading, you start seeing it. Interesting. Yeah, I think we've got some odd propagation going on. If we had a little more time to fiddle with it, it'd be interesting to try to figure out where the path actually is. You're right. Now let's work together, guys, and I think we need to pack up here. All right. This weekend's been kind of crummy for conditions. All right. Okay, who's next? W6CDR. N9JIM. Let me throw you there. Okay, the BY and JIM. Actually, I don't know who's moving faster, but let me see if I can see Brian's signal. Oh yes, there it is. Let me see if I can enhance it at all. AD6A, KB6PI. Again? No,
I'll want to try one more time to work me. I'm on Diablo.
Okay, Brian, go to sideband. Let's just get this knocked out. 86A, I don't think heard anything. N9JIM to basic CDR.
Yeah, I heard little bits of you.
Okay, if you think you have a heading, why don't you put up a carrier? Let me see if I can resolve it. More reasonable.
Another station couldn't hear you here.
Conditions are not conducive to anything except pushing really hard.
Yeah, what happened there was QSB peaks that are about 10 seconds apart.
Yeah, you know what I think it is? I think it's actually a heterodyne between an airplane reflection and the direct path.
I had you on direct though.
Yeah, the airplane path is just watching it on the screen and listening to it. Your carrier would have two signals, slightly different in frequency and so on, and it would wander up and get close to zero beat, stuff like that.
I've been hearing that all day on you guys down there.
Yeah, because I think it's almost all been airplane propagation.
However, I have the strongest signal of the day from Fraser right now. Ours is like 60 over 9.
Wow. All right. Well, let's see if 86FP is any place besides moving to this next stop.
And 86FD driving south of Los Banos.
Okay, well, holler when you get to someplace, and we'll see if it works.
Will do. Should be about 10 minutes.
86A, Dave. You got things going okay on 9JIM? K6ML and 9JIM. I'm in a new location.
Well, then we can work it. How about 150?
150 sounds good. I'll give you a carrier. And Charlie Mike 96 Queen Whiskey.
86IW, 86. Go ahead, 86IW. Hey, Lars, I don't think this is going to work. I don't hear anything from you either. My received noise level is just too low as well. I'm seeing TSP artifacts on the KX3 monitor. So, the PX3 monitor, sorry. So we should knock it on the head. Thanks for trying, 86A.
If you're still there and when I work someone else, then I can have the dish calibrated. So, talk to you later, 86IW.
Yeah, okay, and Lars, we'll stick around and see what happens. We're up for that.
Okay, as soon as I work someone else, then I have a heading. Okay, 86IW.
This is KC6QHP. I'm available whenever you're done with the guys up north.
86IW, 86FP. Want to give it a try, Lars? Yeah, absolutely. Are you calibrated so you can send me a carrier?
I'm not calibrated, but I'll send you a carrier. I'll estimate
Charlie Mike 97, Oscar Whiskey, was that correct?
96 Oscar Whiskey.
96 Oscar Whiskey. Okay. I listen around, 86IW.
Anybody else before I tear down for the evening in 9JIM?
Are you where I work, Jim?
Yeah, I'm in the same place. I worked YXO.
That's good. That's good. I was hoping I'd see some signal from them, but I haven't yet.
They had it pointing your way and they moved it when they talked to me.
Yeah, but considering how little signal that they were getting, All right, I just wanted to check and see if we peaked on each other. All right, maybe a little later we'll try it. I understand 86FP is looking for us.
Yeah, Roger. Shoot me a carrier